Welcome to the CompTIA CySA Plus complete course designed to help you master the skills needed to pass the latest CompTIA CySA Plus certification exam and succeed as a cybersecurity analyst. This course is based on the newest CompTIA CySA Plus exam objective, including the latest updates introduced in June 2026. So whether you are preparing for the CySA Plus exam, advancing your cybersecurity career, or strengthening your SOC analyst skills, this course will provide practical knowledge, real-world examples, and exam-focused guidance every step of the way. So let's get started and take your cybersecurity skills to the next level. So hi everyone and welcome to the Cybersecurity Analyst CompTIA CySA Plus course. So this is another course in my CompTIA series. I have also already covered the CompTIA A Plus, Security Plus and Network Plus courses, and they are available on my channel. So I have over 15 years of experience in cybersecurity and network security, and I have attained over 24 of certifications in these specific domains, mainly the CISP, CCSP, CySA, JNCIP, SEC, etc. So if you have any query regarding any cybersecurity topic or the certifications, this certification or any other certification, you can email me or you can comment on the video and I will respond to your queries. So this certification course is designed as per the latest CompTIA exam version, that is CS0-004 V4, that is being launched at the end of the June 2026. So we have 4 domains and each domain carries a percentage of the overall exam weightage. So as we can see, the first domain, security operation, carries the largest 34% weightage. Second domain is vulnerability management, which is 26%, incident response and management carries 24%, and the last domain, that is reporting and communication, carries the smallest of all these domains, that is 16%. So there are a lot to cover and I will cover each and every topic that is available in the CompTIA exam objectives. So since I am covering each and every topic, so there are a lot of slides, particularly in this first domains. There are over, I think, about 170 slides. So I will try to make the things understandable as easy as possible, but I will also try to go through the slides in a fast manner so that we can cover all the topics in a short span of time, and so that the video do not become too much lengthy. So without further ado, let's get started with the actual topic. And our first exam objective in domain 1 is explain concepts related to system and network architecture in security operations. And our very first topic is logging concepts. So what are logging? So logging is the process of recording events and activities occurring on systems, applications, network devices, security tools for monitoring, investigation, troubleshooting, and incident response. So you can relate this in your environment, in your IT environment, that each and every device, whether it is a network device, whether it is a server, or whether it is a mobile device, any activity or any action that is performed on them, they generate events and activity in the form of logs, and these logs are very important in IT and security operations. Why they matter? So these logging matters to detect security incidents. So from these logs we can detect that something fishy or some security incident are happening. They support through investigation. When incident occurs, then we need to investigate these incidents. Sometimes there are criminal investigation, and for these investigations the logs are very important. So there are some security compliance or regulatory compliance that require that these logs should be kept and stored for specific duration. So we also need these logs for these compliance requirements. So we also need these logs to monitor the health of all these devices, the network devices, servers, applications, etc. And again, in our criminal investigation, they also provide forensic evidence. So what is the log ingestion then? So log ingestion is the process of collecting and importing logs from the various sources into a centralized logging platform such as SIEM. So as we studied, all these devices, they generate logs. So instead of going through manually going manually into each device and going through these logs is humanly not possible. So what we do, we ingest these logs into a centralized platform commonly known as SIEM. So key components of this SIEM solution or this centralized solution include the log sources such as the firewall, endpoint, servers, cloud services, and applications. And these logs are ingested from these devices through protocols. These protocols include syslog, WinEvent, SNMP, NetFlow, and API-based collection. So these are the different protocols that are used by different devices. So for example, a network device may use the NetFlow protocol for with its communication with SIEM solution to send its logs. The Windows Server, Microsoft Windows Server may use the WinEvent. So each device and application use a specific type of protocol. So we have some popular SIEM solution or platforms such as Splunk, very popular, QRadar from IBM, very popular, and the Microsoft Sentinel. These are primary ingestion points, or you can also say these are primary SIEM platforms. So in order for the logs to be ingested by the SIEM solution, we need to configure logs on these devices as well as the SIEM platform. So log configuration determines what events are recorded, how much detail is captured, and where the logs are sent. So these all details needs to be configured. So the key components during log configuration include the log level. So we have different level of logs such as debug, info, warning, error, and criticality. Critical, as you can see that the severity of these log increases from debug to fatal. So we won't want to miss any fatal or error related logs. We may want to miss or even not configure the info logs. So because misconfiguration may lead to either log gaps, so it will be very critical if we miss these logs because these are very important for our system and security operations. But if we configure all type of info logs, then we may generate very excessive noise. That means that we have a lot of logs that are of no use or of very little information to us. So the best practice is to log the minimum necessary information so that we can detect threat, and we also do not overwhelm our storage requirements. So remember that all these logs are stored somewhere. So if we log each and everything, our storage requirement or our storage will be overwhelmed, and then it will be cost prohibitive. So we need to detect all the critical logs that are necessary for our security operation, and we fine tune our logs such that the unnecessary logs or the logs that are of very little information, we can let them go. So exam tip is that too little logging reducing visibility. For example, if we configure only, let's suppose, some fatal logs and we leave out the error or warning logs, we may have the reduced visibility. On the other side, if we log all the levels of logs, we may have very much noise, that is very a lot of information which will be of very little use, and our storage needs will also be very large, and our storage solution will be overwhelmed. So as we study that the logs are basically very important information. These are the critical data from all the systems. Sometimes they are used for forensic investigation, for incident investigation. So the integrity and security of logs is very important. For example, if there is some hacker that intruded inside our systems, stole some data, and if that hacker is able to delete the log or change the log, then we are in a trouble. So the security and integrity of logs is very important. So ensuring that logs remain accurate, complete, and protected from unauthorized modification is very important. So why it is important? Because attackers often attempt to delete, modify, or disable logging to cover their tracks. And protection methods for logs include to encrypt the logs on storage, to use digital signatures so that we can determine that logs are from the original source. Hashing is used for integrity, which ensures that the logs are not tampered with or they are not changed. Write once storage and centralized logging. Write once storage means that once we write the logs to that storage, they cannot be changed. And again, centralized logging is also important. For example, if your server is compromised and the logs is also stored on that server, the hacker can easily delete or change that log. But if the server is configured to send the log to SIEM solution, then this is centralized logging, and if your SIEM solution is secured enough, your logs from that compromised servers are safe, and you can use them to track that hacker and for other investigations. So time synchronization is one of the very important aspects in logging, and we can see why. So we need to ensure that all the devices use the same accurate time source when generating logs, so that we can correlate these logs with each other. So if we have different time at different system, it will be very difficult to know the exact nature of events that occurred during an incident. So why it is important? So without synchronized time, event correlation becomes difficult, attack timelines become inaccurate, and incident investigations become delayed. So the common technology or the common protocol that we use for time syncing among devices is the NTP, that is Network Time Protocol. Another important aspect is log retention. So log retention is the process of storing logs for a specific or specified period according to business requirements, operational requirements, or legal and regulatory requirements. So why the log retention is important? Because it supports an investigation. Let's suppose if there is something happens and in the future the company decides an investigation, or some agency or government institution decides investigation. So it is very important that you have stored those logs that they can support the investigation. So the government or the regulatory agencies may also require some compliance that you need to adhere to, and these may be to store these logs for specific period, enable historic analysis, and provide evidence for audit. So during audits, the auditor may require the logs to certify certain criteria or to look for certain events and other requirements. So consideration during log retention should be storage capacity. So again, as we studied, those logs that are required for compliance requirements that are critical, they should be stored, and other logs that are of little or no use to for the compliance requirement, they are of no use for the audit purposes and other needs, the business needs. So keeping in view the storage capacity, we may want that these logs that are of no use and no importance are not stored. Regulatory compliance is very important. That should be keep in mind when talking about the log retention. Again, your own business policies and investigation needs. So our next topic is operating system concept. So you all know the operating system by itself. our popular operating system, the Microsoft, that is Windows, Microsoft Windows that I'm using right now, Apple macOS or iOS on mobile devices, Android, and of course the Linux. So why the concept of operating system is important for cybersecurity analysts? So analysts must understand operating system internal to detect anomalies, investigate incidents, and analyze logs and recommend hardening. So key OS operating system platforms include Windows, which is most common in enterprises, and it main focus for the analyst is on registry, event logs, and processes. Linux is most common in server and cloud platform, and focus in Linux is on configuration files, permissions, and daemons. And macOS is less common in enterprises, but it is relevant in mixed environment. It is mostly used in user end devices such as laptops. So what is system hardening? So it is the process of reducing the attack surface of an operating system by applying security best practices, patches, and configuration. So what are the goals of system hardening? So the main goal is to improve security, reduce the attack vectors, limit the unauthorized access, and minimize the exploitation opportunities. So what are some common techniques of system hardening? So some common techniques include, the most important and the foremost is to disable unnecessary services or ports. So unnecessary means that they are not used for any business purposes, they are not used in your operations. They need to be disabled, so that when we say to reduce the attack surface, so this is the reducing the attack surface. If a service or a port is not available, is disabled, the attack surface is automatically reduced and it can no longer be exploited. Again, to remove the unused software and unused accounts. So for example, if there are some guest accounts, if there are some user accounts that are no longer used, they should be immediately disabled and removed. Apply security patches and updates regularly from the vendor. For example, if you are using Windows, you need to apply Microsoft released patches and updates as soon as they are released. And enforce least privilege on all accounts. Least privilege means that all the accounts should only have the permissions that they need to do their job and day-to-day tasks. And to enable host-based firewall, so each operating system has its inherent firewall, so that need to be enabled. For example, Windows, Linux has IP tables firewall, Windows has built-in Windows firewall, so you need to turn them on. So now coming over to file structures of these operating systems. So a file structure refers to the organization and storage of files and directories within an operating system. So for example, Windows file structure is, you can see that the core system files are stored in this directory, C, Windows, and System32. Then we see Windows, System32, and config have the registry hive. Registry files are stored over here. And C program files has the installed application, while the C users and then the username, it is where the user account data is stored. Coming over to Linux file structure, so we have the etc, most important directory where the configuration files are stored, /var/log. So we are talking about logs in a moment before. So this is where these logs are stored on the individual systems. For example, the syslog, path.log. Then we have the /bin and /usr/bin. So these are the directory where we have the executables, and then we have the /home where the user directories are available. So what are some critical files in these operating systems? So these are the files that contain sensitive configuration, logs, or system data, and these are the high value targets for the attackers because again they are critical and they have the sensitive configuration and information. So some critical Windows file structure includes SAM that stores local user password hashes and which is a lucrative target for credential dumping, ntds.dit which is Active Directory database and again it is a high value target for attackers. Host file, it is the file that stores the DNS records and it can be modified by the attacker to redirect the DNS queries, and then registry hiles, it contains configuration, auto-run entries and persistent mechanism. Some Linux file structures, so we have the critical files such as etc password and etc shadow. So these two directories stores the user accounts and the password hashes. /etc/cron tab are where the scheduled tasks and are stored, and it may be abused for persistence by the attacker. .bash rc and /bash_profile, it is where the startup scripts are stored, and again it can be used for persistence. It is being in fact used for persistence. And then we have the /etc/sudoers. So these can be targeted by the attacker for privileged escalation. Now coming over to some system processes. So running the program and services, these are the system processes are running program and services managed by the operating system, and analysts may look for, should look for normal versus anomalous processes. So if you know what are the normal program and services that are run by a different operating system, you can also then detect anomalous processes that are not available in a normal operating system. So key characteristics are that legitimate processes usually have non-parent processes. For example, the service host.exe has the services.exe parent, or you can say that this process basically inherits comes from this one. And if there is high or CPU or memory usage or unusual high network activity or unusual network connection, it means something fishy is going on and this is a red flag. So some Windows common processes include ISS.exe, which is used for credential handling and often targeted by attackers, SMSS.exe and CSRSS.exe, including WinInit.exe. These are core system processes, and of course Explorer.exe, which is a user shell in Windows. Then we have some common Linux processes are also known as daemons in Linux. So these are ps-top and htop, and these commands are these processes basically list all the running processes in the operating system. /proc file system is the shows us the live process information. So unexpected root-owned processes deserve immediate investigation of the analyst. So our next topic is infrastructure/system architecture concepts. So why this topic is important for the CySA analyst? So understanding modern infrastructure helps identify misconfigurations, attack surfaces, and anomalies in hybrid and cloud environments. So key modern architectures include cloud native, virtualization, containerization, and APIs, and we will go through each of these one by one. So first one is cloud native. So what is cloud native? Cloud natives means that the applications that are built and deployed entirely within cloud platforms such as AWS, Azure, or Google Cloud Platform key characteristics of the cloud native applications are that they are based on microservices based architecture. They have the auto scaling and elastic resources capability, and these managed services basically replace the traditional on-prem infrastructure. So security challenges of these cloud native infrastructure is that we have now a shared responsibility model. So we have the cloud provider that secures the physical infrastructure, the server, the network devices, the physical security of the data center, while the customer mainly secures the data and access control. So another challenge is that misconfigured storage bucket and identity and access management policies are top cloud attack vectors. So now since we are inside cloud is accessible from anywhere through internet. So if you have a misconfigured storage bucket, storage address, so that is a very top cloud attack vectors because now this is accessible from anywhere, and if it is misconfigured and the data is also accessible, then we are in trouble. So again, we have limited visibility compared to on-premises environment. So in cloud, we don't have the hypervisor level or the hardware level visibility that we have in on-prem. So again, we have limited visibility inside the cloud as we have in our on-prem environment. So our next topic is virtualization. So virtualization is running multiple virtual machines on a single physical host using hypervisor. So we said multiple things. VMs are virtual machines as compared to physical machine, and these are produced or orchestrated through a hypervisor. So what is a hypervisor? So we will study these now. So these are the types of hypervisor. So hypervisor is basically, you can say that this is your physical host. On top of that host, you deploy hypervisor. So traditionally, we used to deploy operating system directly on that host. Now you deploy the hypervisor, and as we can see over here, we are already have this in diagram. This is your physical host. You have the hypervisor on that host. So this is, you can say, the virtualization OS, you can name it. And on that hypervisor, you can then have multiple VMs. So each VM has its own operating system. It may be Windows, it may be Linux, and you can have tens and hundreds of these VMs on a single host. So we have two types of hypervisor. Number one, that is typically used in data center and enterprise environment is type 1, that is bare metal. So in this case, hypervisor run directly on hardware, such as in this case. An example of type 1 hypervisor are VMware ESXi, Microsoft Hyper-V, and Xen. So this is the type 1. As we can see, we have the physical host, and on this host we have directly installed the hypervisor, and then on using the hypervisor we orchestrate multiple VMs. Number 2 is type 2 hosted, also known as hosted hypervisor. So this type of hypervisor run on top of host OS, for example VirtualBox and VMware Workstation. For example, if you install Windows operating system over here, and then on this Windows OS you install hypervisor over here. So this is type 2, and inside this hypervisor then you create VM. This is the type of hypervisor that we usually use on our laptops, such as the VirtualBox or VMware Workstation. So some security challenges in virtualizations include VM escape. So it is a phenomena where attacker breaks out of VM to access hypervisor or other VMs. VM sprawl is where we have unmanaged VMs that increase the attack surface. Snapshots that we create using virtualization may contain sensitive data if not properly secured. So if you create a snapshot of VM, they should be properly secured, because if they contain sensitive data and they are compromised by the attackers, it means we may lose that sensitive data. So hypervisor compromise affects all hosted VMs. So since hypervisor is the platform that manages all those VMs, so if this hypervisor is compromised, it means all your related or hosted VMs are, you can say, compromised as well. Our next topic is containerization. So containerization is a lightweight virtualization method that packages application with their dependencies into container. It runs on shared OS kernel. So if we see here, we have again a physical host, a server. So as against the virtualization, instead of hypervisor, we have the host operating system. Then this may be Linux, this may be Windows. On top of that, we have the, you can say, containerization engine or Docker engine, and on top of that, we have the containers, and inside each container, we have the application. So each container has all the libraries, the dependencies that are required for these applications. So this gives us very, you can say, lightweight, if you say these VMs. So each, in the case of VMs, each VM has its own operating system. Here, the container do not have its own operating system. It uses the operating system kernels, shares it. It is shared among all the containers. So that's why it is very lightweight. It only has the required libraries that are used by the application. So characteristics, again, it is very lightweight as compared to VM. It has fast deployment, so you can you can take this container and you can fastly deploy it anywhere else that has the same Docker engine and same operating system. Very portable. As I said, it is portable and it is consistent across environment, because it carries along the same libraries and dependencies to each environment. So some you can say the comparison between the VMs and containerization. So size is that the virtualization VM is large because it has full OS, and the containers are small because we have the application only and its dependencies. Startup time of VMs are slow because it needs to start the complete operating system. The startup time of container is very fast because it does not need to start all the full operating system. It needs to run only the required libraries and dependencies. Isolation inside the virtualization between VMs is strong, which is controlled by the hypervisor. In containers, it is weak because the containers share the same operating system kernel, and density of the VMs is lower, while in case of containers it is higher. Density means that you can, let's suppose if you can deploy 100 VMs on this specific server, you may deploy 200 containers on the same server because the containers require less resources, so their density is high. So security concerns are again container escape. These are for container. Same like the VMs, we may have the container escape from this environment and privilege escalation. Insecure images of container, exposed forks and weak secrets management, and supply chain attacks. That is, if the container base image is compromised, all the resultant containers will also be compromised. Our next topic is API, that is application programming interfaces. So an API is a set of rules and mechanisms that allow applications and systems to communicate and exchange data. So common API types include REST API, which is most common and uses HTTP methods, that is GET, POST, PUT, DELETE. Then we have the SOAP API, which is XML based and is used in legacy enterprise environment. And lastly, we have the GraphQL, which is a flexible query based API. So what are some security concerns with the APIs? So the broken object level authorization, that is BOLA, is accessing other user data. So this is one security concern. Next is API key exposure. So hard-coded keys in source code or public repository may be exposed. Excessive data exposure. So APIs returning more data than needed may expose data. Rate limiting bypass, so enabling brute force or enumeration attacks through APIs. So what are some controls? So some API security controls are authentication of the APIs, authorization, their rate limiting, encryption, and input validation. So now coming over to our next topic, which is device management concepts. So the processes, technologies that are used to securely manage, monitor, and control various devices in an organization's environment. So main categories of device management include MDM, that is mobile device management, and endpoint device management. So why device management is important for CySA plus analyst? So it is because devices are common entry point for attacks, whether they are mobile devices or whether they are endpoint devices like servers. So we need to protect, we need to detect anomalous behavior inside devices, enforce security policies, and respond to the incident in these devices. Mobile device management, that is MDM. So it is the centralized management of mobile devices such as smartphone and tablet to enforce security policies and ensure compliance. So the key capabilities that MDM provides include the remote wipe that can be used to erase device data if it is lost or stolen. Policy enforcement includes enforcing the PIN on the device, encrypting the data on the device, and application restriction. App management gives you control on the device such that which applications can be installed and which application cannot be used or installed on the device. And geolocation tracking, so you can locate the device when it is lost or stolen. So common MDM platforms include the Microsoft Intune, VMware Workspace ONE, JAMF from Apple, and Google Workspace. So some security risks with the mobile devices include that they may be jailbroken or rooted, and such devices can bypass the security controls, including that of the MDM. So unmanaged personal applications can leak the corporate data. So lost devices that do not have the remote wipe capability have the risk of data breach, and public Wi-Fi usage on these devices exposes the data on these devices as well as the traffic interception that goes through these devices using the public Wi-Fi. Next is the endpoint management. So endpoint is managing and securing the endpoints that include the laptop, desktop, servers, and workstation throughout their life cycles. So key components of endpoint management include endpoint protection platform, that is EPP, and these include the antivirus, firewall, and disk encryption. Endpoint detection and response, EDR, which is the continuous monitoring, behavioral analysis, and threat hunting. And unified endpoint management, UEM, which combines the MDM and traditional endpoint management. Some security concerns with the endpoints include that the unmanaged or rogue endpoints can introduce blind spots outdated software and missing patches are the primary exploit targets for the attackers. So lateral movement through endpoint often occurs after the compromise of one or more endpoints. Lateral movement means that going from one device to next and next within the organization after one device is compromised. USB and removable media can bypass perimeter controls. So since these have no network connectivity, the perimeter security such as firewall can be bypassed through these portable and removable media. So what is the difference between endpoint management and mobile device management? So mobile device is basically include the smartphones and tablet which are mobile, and endpoints are laptop, desktop and server. Mobile devices are managed through MDM, mobile device management, while the endpoints are managed through EDR and EPP. So the mobile device has the flexibility and focus on mobility, while the endpoints are basically used inside the enterprise systems. Mobile devices has the risk of loss and theft, while the endpoint has the risk of malware and hacking or other compromises. So next topic is network architecture concepts. Network architecture refers to the design and structure of network components, connections, security controls, and access methods within an organization. So why does the network architecture concepts matter? It is because modern networks are complex and distributed. Analysts must understand these architectures to detect misconfiguration, monitor threats, and recommend secure design. So as long as you don't understand how the packet goes from one device to another, how the data flows inside the network, what is the network components that come together, what is the TCP/IP, all these concepts are very important. So as long as you don't understand them, you cannot secure them. So for security, first you need to understand the basic of networking, the basics of operating systems such as Linux, and then you can secure them. So some modern network architectures include the Zero Trust Network Architecture ZTNA, Secure Access Service Edge, SAS also called as SASE, and the Hybrid Cloud. So the first one is Zero Trust Network Architecture or ZTNA. So it is security model that assumes no implicit trust. This means that every user, every device and application must be continuously verified before granting access. Never trust, always verify. So traditionally the slogan was trust but verify. Zero trust architecture slogan is that you should never trust and always verify, even if the device or the application is inside your perimeter or inside your organization. So no user, device or application is trusted automatically, even if it is located inside the corporate network. Every access request must be authenticated, authorized and continuously validated. So what are the core principles of the Zero Trust Network Architecture? So these include, as we said, verify explicitly. It means that every access request must be authenticated and authorized regardless of the location of the device. Least privilege access means that user receive only the permissions required to perform their job, no less, no more. And assume breach, which means that the organization operate under the assumption that attackers may already be present inside their network. Next is the Secure Access Service Edge or SASE. This is the cloud native framework that converges the network security and wide area networking WAN into a single service delivered from the cloud. So some SASE components include the SD-WAN, that is software defined wide area network. So it is the software defined wide area network for optimized connectivity of WAN. CASB, which is Cloud Access Security Broker, that gives visibility and control over cloud application usage. SWG, that is Secure Web Gateway, that gives us the filtering capability of malicious web traffic. And as we said, ZTNA, which replaces the traditional VPN based security with identity based access. And FWAS, or Firewall as a Service, which is cloud delivered next generation firewall. So key benefits of SASE include that security and networking are delivered from the cloud, no on-premises appliances are required or included in this architecture, consistent policy enforcement regardless of the user location. It is ideal for remote workforce and branch office environment, and it reduces complexity of managing multiple point security products. So why this architecture is relevant for security analysts? So all traffic flows through SASE platform, which gives us a centralized visibility. So logs from SASE feeds are directly fed into SIEM solution for correlation. Some vendors of this platform include Palo Alto Prisma Access, Cisco Umbrella, Zscaler, and Netscope. Our next topic is hybrid cloud. So what is hybrid cloud? So IT environment that combines private cloud or on-prem or dedicated. So the private cloud may be on-prem or dedicated, and when we combine it with the public cloud, which may be from Amazon, AWS, Microsoft Azure, or Google Cloud Platform services connected for data application sharing. So in a nutshell, the hybrid cloud is basically the combination of the public cloud, private cloud, and traditional on-prem infrastructure. When you mix these things, for example, when an organization has the on-prem infrastructure as well as a public cloud, they have the hybrid cloud environment, or you can say they have the hybrid environment. So some architecture components of the hybrid cloud include the on-premises system, which are legacy systems that may include sensitive data, and some application that may require low latency, that why they may be kept on-prem. Private cloud is dedicated cloud environment for a single organization, such as some government agencies or for some government department. Public cloud is shared infrastructure that is shared among multiple customers, such as AWS, Azure, and GCP. And the orchestration layer basically manages the workloads across all the environments, such as the on-prem and the cloud, the public cloud environment. So some security challenges of the hybrid cloud, and the first one is inconsistent invisibility. So different logging and monitoring tools across environments. So in hybrid environment, you have the traditional on-prem infrastructure, you may have the public cloud. So for both of these environments, you may use different tools, and so you may have inconsistent visibility of your overall environment. Next is identity sprawl, again managing users and permission across different environments. So you may have identity sprawl. Data sovereignty, that is ensuring data stays within the required geographic boundaries. So in traditional on-prem infrastructure, we don't have the data sovereignty issue, but in public cloud, this issue is particularly of importance in public cloud, because your data may reside somewhere else in some other country, while there may be regulation that required, such as GDPR, which is a EU law that requires that EU citizens' data should reside inside the EU boundaries. So, it is data sovereignty also may be issue when you are using hybrid cloud environment and some of your data is inside public cloud. So, for such cases, the sensitive data organization do such that the sensitive data is stored on-prem while other non-sensitive data and for non-sensitive tasks they use the public cloud. Misconfiguration risk, so hybrid cloud increases the complexity and there may be chances of misconfiguration and security gaps. Shadow IT is unmanaged cloud usage outside IT visibility. Our next topic is identity and access management, that is IAM concepts. So, identity and access management is the framework of policies, processes and technologies that manages digital identities and control access to resources. So, what are the digital identities? One example is username and password, digital certificates. These all are digital identities. And what are the parameters or what are the components of IAM? These include authentication, authorization, then user management and central repository for all the digital identities and users. So, key features of the identity and access management include that it may provide us with the single sign-on solution, role-based access control, attribute-based access control, just-in-time access identity for privileged users and federation, for example, through SAML and OAuth. So, common platform for digital for identity and access management, important ones are Microsoft Entra ID, that is Azure AD. Previously, it was known as Azure AD, Okta, and Ping Identity. Inside identity and access management, we have the privileged access management or PAM. So, it is the subset of identity and access management and is focused on securing, monitoring and controlling privileged accounts. So, privileged accounts are those that have the more access, or you can say the most access inside the environment. These accounts can do nearly all the tasks that other accounts can't. For example, the admin account in some system, they are user account, similarly service accounts. So, these accounts have elevated privileges. So, what are the core privilege access management system capabilities? So, they may give us the privileged account discovery. So, for example, we have this new system, we introduce it inside our organization, our environment. It may help us identify our privileged accounts across the environment. Just-in-time access is granting elevated privileges only when needed and auto-revoke after use. So, since the privileged accounts have the escalated privileges, it is very risky to use them all the time for all the tasks. So, they are only used when they are required and then automatically revoked. Session recording, so record and audit all privileged sessions. So, whenever the privileged accounts are used, their tasks, their actions are recorded for audit purposes. Password vaulting is to store and rotate the privileged account credentials automatically. Next is the authentication and authorization methods inside identity and access management. So, authentication is verifying who you are or who are you, usually through a username and password. Authorization is what you are allowed to do after authentication. So, after authentication, we have the authorization, and inside authorization, the user is allowed to do certain tasks. So, both of these must work together. Authentication without proper authorization still leads to breaches. So, if you authenticate a user but you give this user unnecessary privileges and access to unneeded application, this may also lead to breaches. So authentication methods, authentication is verifying the user identity. There are multiple authentication methods such as something you know. These include the password and PIN, something you have, such as token, smart card, and authenticator app usually on your smartphone, something you are, such as your biometric, your fingerprint, your facial recognition, and somewhere you are, which is location based. And so if you combine multiple of these, for example, something you know and something you have, then this type of authentication method is known as multi-factor authentication, and there are also passwordless authentication. For example, if you combine the biometric and the authenticator app, you have a passwordless authentication method. What are some authorization methods? So these include RBAC, that is role-based access control, where access is based on the job role. For example, finance user may have a separate role, HR have a different role, IT department have different roles. So based on these requirements, we may have different role, and user in these departments may be given users according to these roles. ABAC is attributes-based access control, where access is based on user attributes and context. MAC is mandatory access control, where access is based on security labels and clearance level. So these are system enforced access, and these are used in very high security environment, such as in military and other intelligence agencies. DAC is discretionary access control, where resource owner control access permissions. So some key protocols in authorization and authentication, these include SAML, which is XML based single sign-on for web application. So for SSO in web application we use SAML. OAuth 2.0 is authorization framework for API access delegation. OpenID Connect or OIDC is identity layer on top of OAuth 2.0. Kerberos is ticket-based authentication used in Active Directory environments, and LDAP is Directory Service Protocol for user authentication and lookup. So our next topic is secret management. So what is secret management? It is the secure storage, rotation, and access control for sensitive credentials, API keys, certificates, and encryption keys. So key practices for secret management include a centralized secret vault, automatic rotation, least privilege access to secrets, auditing and monitoring of secret usage, and to avoid hard coding secrets in code or configuration files. Some common tools for secret management include HashiCorp Vault, AWS Secret Manager, Azure Key Vault, and Google Secret Manager. So now coming over to encryption techniques. So encryption converts readable data, that is plain text. So what we are seeing here is plain text into unreadable format, that is ciphertext, using algorithms and keys. So data protection encompasses broader strategies to safeguard information. So these are some types of encryption. You must know and differentiate between them. So symmetric key is the type of encryption that uses same key for encryption and decryption. And some popular example of symmetric keys are AES, that is Advanced Encryption Standard, AES 256192. So this is the 256 is the length of the key, and triple dash. Then we have so for data encryption in VPN, for data encryption on storage, we usually use the symmetric because it is efficient and it is fast for bulk data encryption. You should remember this point. Asymmetric is also known as public key encryption. So in this case, we have two different keys, one public key and one private key. So if you encrypt with one key, you can decrypt with other. For example, if public key encrypts, the private key decrypts, and vice versa. If private key encrypts, the public key decrypts. And the example of asymmetric encryption include RSA and ECC. Then we have the hashing. So hashing is not actually, you can say, an encryption. It is a one-way transformation and it is not reversible. What does this mean? This means that if you pass this text through hashing algorithms and you have some type of hash, you cannot convert this hash back to this plain text. So why then hash used? So hash are used for integrity. You convert text to hash, you send it to the user. The user over there then convert the text again to the hash. The user then receiver compares the two hashes, one that is converted by the user himself or herself, and the other that was received with the text. So if both of these hashes are same, it means the data was not tampered or corrupted during transmission and data integrity is intact. So hashing is used for data integrity. Some common example of hashing algorithms are SHA-256 and MD5. Hybrid encryption, where we combine both the symmetric and asymmetric, such as inside TLS and SSL. So why we use hybrid? So as I said, we use symmetric encryption for data encryption, while asymmetric is used for the transportation or for exchange of symmetric keys. So if we have this party A and party B, if they want to encrypt data using the symmetric key, so how as we said, in symmetric they must have the same key. So how this key is exchanged? If A is in, let's suppose they are geographically distant in some different countries, so for this key exchange, for secure key exchange, we use the asymmetric encryption, and for data encryption we use the symmetric encryption. So that's the use cases of symmetric and asymmetric. So in use cases, encryption may be used for data that is stored in storage, for data at rest. So it is used for encrypting data stored on disk and databases. For example, we have the BitLocker inside Windows. We can use it to encrypt data inside our hard drive. Similarly, AES, as we studied, is the symmetric encryption algorithm. It can be used for data encryption at rest. So AES or symmetric encryption is very, very fast and efficient. So for bulk data encryption, we use AES. Data in transit is protecting data moving across networks, and for data in transit, we usually use VPN such as IPsec, HTTPS, and TLS 1.3. And data in use that is actually used by the user, or the data that is actually inside the processing or memory. So protecting data while being processed, and for this we have emerging techniques such as confidential computing. So key management concepts include, or we can say the best practices of key management include: key management is the most common encryption failure. So if your key management is poor, if your keys are, let's suppose, compromised, your encryption will also fail. Key must be rotated regularly and stored securely. Rotation means that the keys must be changed regularly and they must be securely stored. So compromised keys render encryption useless regardless of the algorithm. So even if you have very strong algorithm and very long and strengthy key, but if the key is compromised, everything else is useless. So now coming over to data protection concepts. So the core principles of data protections are confidentiality. So confidentiality is mainly ensured through encryption and access control. Confidentiality is the basic principle, which means that data should only be accessible and visible to authorized users. Then we have the data integrity. As we said in the previous slide, for integrity we use hashing, and integrity means that data must be intact and complete, and it must not be changed or tampered. So we use hashing, digital signatures, and checksum for data integrity. For data availability, we have backups, redundancy, and RAID. RAID is redundant array of independent disks. So it is combining multiple hard drives for redundancy, so that let's suppose if one drive fails, we can still recover the data from the redundant drive. So what are some key data protection methods? So as we studied data at rest, for data at rest we use disk encryption or database encryption. For data in transit we use TLS, IPsec, and VPN. For data in use we use memory encryption and secure enclaves such as TPM. We also use practices such as data masking, tokenization, and anonymization, and we use tools such as data loss prevention to prevent data exfiltration outside the organization. So some best practices for data protection are to do the classification of data. So data should be classified such as public, private, and confidential, so that the controls are applied accordingly. So for the public data we may not use any control, but for confidential we may use control or a set of multiple controls. Then we use the key management and rotation as we studied in the previous slides, and regular backup of data with immutable storage. Immutable storage means that the storage data on the storage should not be changed. It should be write once storage. So key data protection frameworks include GDPR, which is a European data privacy regulation, very important. HIPAA is a US healthcare data protection that is used for protection of patients' data in healthcare system. PCI DSS is payment card industry data security standard that is used for protection of payment card data. And NIST SP 800-53 is a comprehensive security and privacy control framework. Now coming over to critical infrastructure concepts. From critical we mean the power grids, the nuclear energy, and other industrial setups. So systems and assets that are essential for society's functioning such as energy, water, transportation, healthcare, etc. So why these are important? So these environments are of high value targets for nation state actors and ransomware. So CySA analysts may deal with OT and ICS security incidents. So inside ICS we have the operational technology or OT. So OT refers to hardware and software that monitors and controls physical devices and processes. Unlike IT systems that processes data, OT systems control physical world operations. So they are found in power plants, manufacturing facilities, oil and gas pipelines, and water treatment plants. So what are some OT security challenges? So these include the legacy systems are not designed with security in mind. So these systems are generally air-gapped network, and air-gapped network increasingly connecting. So traditionally these systems were air-gapped, but now they are increasingly being connected with the IT, and IT, as we know, have the inherent security risk. So vendors often require direct remote access to these systems for maintenance. Patching of this system is increasingly and extremely difficult because we cannot take these systems offline for patching or for testing the patches on this system. And traditional IT security tools can crash or disrupt OT equipment. So industrial control systems. So ICS is the broad category of systems used to monitor and control industrial processes. So it encompasses OT environments across all critical infrastructure sectors. So industrial control system components include PLC, that is programmable logical controller, which executes control logic for physical processes, for example open valve, start motor. RTU is the remote terminal unit that collects data from field devices and sends it to control center. HMI is human machine interface, that operate interface for monitoring and controlling processes. And historian is the database that records process data over time for analysis. So I see some industrial control system attack example. So Stuxnet, a very popular malware that was designed for the Iranian nuclear facility and centrifuge. So this malware destroyed Iranian, or you may say damaged Iranian nuclear centrifuge by targeting the PLC, programmable logical controller. Then we have the Ukraine power grid attack in 2015 and 16, and similar attacks also happened after the Ukraine-Russian war. So ICS attack caused widespread power outages. Then we have the Old Smar water treatment in 2021, where the attacker attempted to poison the water supply via the ICS access. So as we can see from these attacks, the security of ICS is very critical. So what are some best ICS security practices? So network segmentation between IT and OT ICS network. Because the IT network is accessible if it is not air-gapped from anywhere through internet. So it is very important that these two networks are air-gapped and segmented. So application whitelisting on ICS workstation. So the workstation that are connected to ICS, they must have application whitelisting. Whitelisting means that you allow only the required application that are required to run these control systems, and no other application should be allowed to work or install on these systems. Strict remote access control with multi-factor authentication and regular backup of PLC configuration and logic. Then we have the supervisory control and data acquisition, that is SCADA. So SCADA is a type of industrial control system that is used to monitor and control geographically dispersed infrastructure. It collects real-time data from remote field services and provides centralized visibility. It is common in utilities such as electricity, water, gas, oil pipelines, and transportation systems. So SCADA architecture include field devices, which are sensors and actuators at remote sites, RTUs and PLC that collect field data and execute commands, communication network that link field sites to control center through radio, cellular or fiber communication. Master station or MTU is the central control and monitoring point, and HMI SCADA software where we have the operator interface for visualization and control. So some SCADA security concerns include, so SCADA was originally designed for reliability, not security, and there are no built-in authentication in many protocols. So increasing internet connectivity exposes the previously isolated system to various risks. So the SCADA use proprietary protocols such as Modbus, DNP3 and IEC 61850 that lack encryption by default, and they have single point of failure, so compromise of master station affects the entire infrastructure. So our exam objective 1.2, given a scenario, analyze indicators of potential malicious activity. So let's get started. And the first topic is network indicators. So what are some indicators over the network of a malicious activity? So network related indicators are unusual or suspicious network activities that may suggest unauthorized access, reconnaissance, malware infection, or other malicious behavior. So anything out of ordinary on the network may seem or may indicate a malicious behavior. And some common indicators include if you have rogue devices, enumeration, anomalous activity, and activity on unexpected ports. So we will discuss each of these one by one. So exam type questions are heavily scenario based and focus on what does this indicate and what is the next step. So you must understand that what each of these indicator or indication means and what happens or what are the, you can say, the attacker steps inside a malicious activity or inside a system compromise. So the first one is rogue devices. So rogue devices are unauthorized devices connected to the network. For example, they may be laptop, Internet of Things devices, Raspberry Pi, or attacker placed some other hardware. So some common indicators include unknown MAC addresses in your DHCP logs or tables. Similarly, devices with no asset management record. So usually organization has record of all the devices inside their asset management. So if a device is not present in the asset management record, it may be rogue device. Or new devices appearing in network scans through when you scan network using an Nmap and Nessus. So some common detection methods include network access control NAC, 802.1x authentication, MAC address filtering and port security, and continuous network monitoring. So these are the detection method, or you can also say these are the protection methods to protect against the rogue devices. Next is the enumeration. So what is enumeration? Enumeration is where attackers actively probe the network to discover host, services, user, shares, and vulnerabilities. So this is a type of scanning for the resources done by the attackers. So some common techniques and indicators of enumeration include multiple failed login attempts or SMDV/RDP probes, DNS zone transfers or excessive DNS queries, port scanning or service enumeration through Nmap and mass scan, and LDAP or SNMP queries for user and group information. So what logs to check for enumeration? So firewall logs showing repeated connection attempts, SIEM alerts for reconnaissance patterns, and unusual traffic from a single internal or external IP. Next is the anomalous activity. So when the network behavior deviates from the established baseline, that is an indicator of anomalous activity. Key examples include unusual data volumes, unusual data uploads and downloads, traffic to known malicious IP addresses or domain command and control servers, abnormal protocols such as HTTP on port 53 and DNS tunneling, and beaconing behavior, which is periodic small connections and lateral movements between segments inside the organization private network. So some common tools to detect the anomalous activity are SIEM solutions such as Splunk or Microsoft Sentinel. We also have the QRadar from IBM, network behavior anomaly detection, that is NBAD, Zeek, Suricata, and IDS and IPS solutions. Next is the activity on unexpected ports. So traffic using non-standard or unexpected ports for a given protocol. So for example, SSH uses port 22. So instead, if it uses port 443, it means something fishy is going on. The attacker is hiding the SSH protocol RDP on port 80 or 443. So RDP usually uses 3389 port number. HTTP and HTTPS on random high ports. So HTTP uses the port 80 and HTTPS uses port 443. So if some random ports are used, it is an indication of malicious activity. Non-malware ports, for example, Tetra 4, Tetra 6 for backdoors. So why attackers use unexpected ports? So attacker use non-standard ports to bypass firewall rules and security tools. So for example, firewall may have blocked the port 22 for the incoming traffic, but it may be allowed, traffic may be allowed on port 443. So to bypass this restriction, they use the non-standard port. Legitimate services usually run on well-known ports. So some host-related indicators. So host-related indicators are suspicious activities occurring on individual systems that may suggest compromise, malware infection, unauthorized access, or insider activity. So some key host indicators include resource consumption, unauthorized software, anomalous activities such as rogue processes, lol bins, file changes and data exfiltration, and unauthorized configuration changes. Detection of host-related indicators include through task manager and resource monitors inside Windows, using the top, htop, and iotop commands in Linux, and using EDR tools such as Microsoft Defender and CrowdStrike. So unauthorized software and anomalous activities. Unauthorized software are applications that are not used by the organization or by IT. So the term is used for unauthorized software use, which is shadow IT, using cracked and pirated software, and remote access tools such as TeamViewer, AnyDesk used without approval activity. Suspicious or rogue processes include processes running from unusual locations such as temp, app data, masquerading such as servicehost.exe instead of servicehost.exe. So using this is 0 instead of O. So this is the legitimate process and this is a masqueraded process, and high privileges with no clear purpose. So file system changes and data exfiltration. So file system changes when a new or changing new or modified critical files, creation of suspicious files in user directories, and alter system files or logs, that is time stomping. Data exfiltration is large outbound transfer to external IP addresses, unusual file access pattern of sensitive data, and use of cloud storage such as Dropbox, Mega, or email for exfiltration. Unauthorized configuration changes is modification to system settings, security controls, or policies without approval. Examples include disabling the antivirus and Windows Defender, changing the firewall rules or registry keys, and adding unauthorized users to admin groups, and modifying the group policy objects or GPUs. So detection can be done through configuration monitoring tools, fire integrity monitoring, and change management logs. So some application related indicators. So service disruption, unexpected crashes or unavailability of critical devices. Services, when services stops or are disabled, for example, security services. Anomalous application activities, when applications are making unusual network connections, when web servers are serving malicious content and database queries showing injection attempts. Some cloud-related indicators, so these include unusual login location or times, high cost resource usage, for example, crypto mining inside the cloud, and abnormal API calls or data transfer. Resource compromise, so compromised storage buckets, for example, public S3 buckets, hijacked virtual machines or containers, and identity and access management role abuse. Next is the social engineering. So in social engineering, we have the typo squatting. So typo squatting registered domain names with slight misspelling of legitimate sites. So this targets users who mistype URLs and land on attacker-controlled pages. For example, we have the popular google.com domain, and if the attacker may register it with the capital I instead of L. So they look similar. Similarly, PayPal. So here we have the 1 instead of L. Amazon, so it is similar to Amazon. So registering the domain with RN, that is similar to M. And Microsoft, so register this domain which have an extra T to typo squat the original Microsoft domain. So purpose is credential theft, malware delivery, and phishing. Another social engineering trick is the URL shorteners. So URL shorteners, such as we have the websites that provide this facility, such as bit.ly, tinyurl.com, obscure the true destination of a link. So attackers use them to hide malicious URLs in phishing emails and social media. So why attackers use URL shorteners? So they hide malicious domains from email security filters, bypass reputation-based URL blocking, makes link appear legitimate and trustworthy, and can be redirected to new destination after discovery. So analyst action should be to expand shortened URL before investigating them. So identity-based indicators include identity and access management account compromise. So compromised accounts are the leading cause of breaches. Attackers gain legitimate credentials. Compromised identity and access management accounts provide access while appearing as normal user activity. So indicator of identity and access management account compromise: login from previously unseen IP address or geographic location, successful login after multiple failed attempts, true brute force success, login at unusual time. So for example, if the employee usual timing are from 9 to 5, but if the login happens at 3 a.m., it is then an indicator of the compromise. Sudden access to resources the account has never touched before. So these all are some of the indicators of a compromised account. Some identity-based indicators. Unauthorized access occurs when a user accesses resources beyond their authorized scope, and it can be external attacker, compromised insider, or privileged abuse. Key indicators of unauthorized access include access to resources outside the job role, privileged abuse. Privileged abuse means escalating the privileges or using the privileges to do tasks that are not meant to be done. Accessing restricted data and unusual login activity, as we said, that log in at a very unusual time, such as at 3 a.m. Identity-based indicator again include impossible travel. Impossible travel occurs when a user authenticates from two geographically distant locations in an impossible short frame, an impossible short time frame. For example, if a user logins from USA and after 5 minutes same user logins from India, so it is impossible to travel in such a short time from US to India. It means the account is compromised. Strong indicator of account compromised, one login must be from the attacker. So if the legitimate user is from USA, then the attacker may be based in the inside India. For example, user logins from New York at 9 a.m. and same user logins from London at 9:45 a.m. So this travel is physically impossible, and it is a strong compromise indicator. So identity-based indicators considerations include, so we must include some considerations before saying that this indicator is a compromise. So VPNs and proxies can create false positives. So user may route through international VPN. So if the user is using VPN, and let's suppose the user that was using the resources from New York, and now the VPN location is set to London, so this consideration must be kept in mind. Cloud-based system may show logins from data center locations rather than user location. So for example, if the user is using resources or is being logged in from the data center inside London, then the location may be shown as the London. So correlate with other indicators before concluding the compromise. So now coming over to email related attacks. So business email compromise, BEC, is a targeted attack impersonating executives or vendors to trick employees into transferring money or revealing sensitive data. Some common indicators of email compromise include emails with urgent language and unusual request, slight variation in email addresses, for example, CEO@company.com. So here, using this Cyrillic A, again request to update payment details or wire money through spoofed domains. So for example, there is a scenario if the chief financial officer receives email from CEO that asks to wire funds urgently. So this is a classic business email compromise scenario. Objective 1.3, given a scenario, use different tools to determine malicious activity. So now we will study some different tools to determine that what malicious activity is going on. First one is the CyberChef, which is used for decoding and parsing. So it is a free web-based tool by GCHQ for decoding, encoding and transforming data. So it is the Cyber Swiss Army knife. And some common uses of this tool include decoding base64, URL encoding, hex and ROT13, parsing logs and extracting indicators of compromises, cracking simple ciphers, and data carving and format conversion. So why it is valuable? Because no installation is required. It supports recipes, that is, you can use saved workflows inside the tool, and it is excellent for malware analysis and obfuscated payloads. Now coming over to packet analysis tools. So packet analysis tools are used to capture and inspect network traffic to identify malicious patterns, command and control communication, data exfiltration or exploits. So some key packet capture or packet analysis concepts include PCAP, which is packet capture, that is the file format storing captured network packets. Promiscuous mode is the network interface card. In this mode, the network interface card captures all the traffic on the segment, not just the traffic that is destined for it. So it listens to and captures all the traffic. Full packet capture is when it captures the entire packet including the payload. NetFlow captures the metadata only, that is IP addresses, port numbers and bytes, not the full payload. And deep packet inspection DPI analyzes packet content beyond headers. So a very popular packet analysis tool is known as Wireshark. So it is most widely used graphical packet analyzer in the world. It is open source and available for Windows, Linux and Mac OS. And it captures live traffic or analyzes saved PCAP files. So key features of Wireshark include deep packet inspection, powerful display filters, follow TCP stream, and export information, that is to highlight anomalies. Common use cases include analyzing suspicious connections, identify C2 traffic, and reconstructing sessions. For example, the follow TCP stream can be used to reconstruct different sessions. Next, we have the TCP dump. So it is a command line packet capture tool for Linux and Unix systems. It is lightweight, pre-installed on most Linux distributions, and it is ideal for capturing traffic on remote servers where GUI is unavailable, and the output can again be saved as PCAP for analysis in Wireshark. So key components or key commands of TCP dump include TCP dump -i -0. So -i means that interface. So this is the interface that we want to capture traffic on. So after -i flag, you can give the interface number on which you want to capture the traffic. TCP dump -nn port 80. So here you can filter traffic by ports, and -nn means that no name resolution is required. TCP dump -w capture.pcap. So here the TCP dump capture traffic is saved to this file for later analysis. W means, you can say, to write the traffic to this file. So TCP dump is best for quick capture on servers, scripting and automation, and low resource environment. Then we have two another tools, Snort and Suricata. So Snort is an open source Snort is an open source intrusion detection and prevention system. It has a signature-based detection, and it is widely used and highly customizable. So Suricata is modern high-performance intrusion detection and prevention system. It supports multi-threading. It is better for protocol detection and file extraction, and it has the native support for YAML rules. So common use case of these tools include real-time alerting on malicious traffic and analyzing PCAPs offline. Next, we have the Zeek, also known as BRO. So Zeek, formerly known as BRO, is a network security monitoring platform focused on network visibility and behavioral analysis. Key strengths of Zeek includes it generates rich logs such as HTTP, DNS files, and connection logs, protocol analysis and anomaly detection, and scripting language for custom detection. So it is best for long-term network forensics, detecting sophisticated attacks, and extracting files from traffic. For example, a use case scenario for Zeek would be that there is a suspicious domain resolution. So Zeek logs show detailed DNS and HTTP activity for investigation. So these tool comparisons, so CyberChef is for decoding, it is best for data transformation and indicator of compromise. Interface is GUI and its strength is speed and flexibility. Wireshark is for packet analysis, it gives us detailed inspection. Interface is GUI and its strength is user friendly and deep analysis. TCP dump is again for packet capture, its strength or it is best for quick capture. Interface is CLI and its strength is that it is lightweight and fast. Snort is intrusion detection and prevention system. It is best for signature based detection. Interface is both CLI plus rules and its strength is that it has a mature rule set. Suricata is again intrusion detection and prevention system. It is best for high performance detection. Interface is CLI plus rules and its strength is the modern multi-threaded architecture. And Zeek is for network analysis and it is best for log generation and forensic. Interface is a framework and its strength is rich metadata and scripting. So now coming over to our next topic, that is log analysis through SIEM, that is security information event management. So security information and event management, or SIEM, is a central platform that collects, correlates and analyzes logs from multiple sources. Key capability of SIEM include real-time alerting, correlation rules, dashboards, and compliance reporting. Some popular SIEM platforms are Splunk, Microsoft Sentinel, ELK Stack, and QRadar from IBM. And use cases of SIEM include detecting anomalies across logs, incident timeline creation, and threat hunting. Threat intelligence platform, so we have Open Threat Exchange, that is OTX. So it is free community driven threat intelligence platform by Alien Vault, that is AT&T Cybersecurity. It is one of the largest open threat intelligence communities globally and it is available at otx.alienvault.com. And what are the analyst use cases? So to look up for suspicious IP addresses found in logs, check file hash from endpoint against known malware databases, subscribe to pulses relevant to your industry sector, and enrich SIEM alerts automatically via OTX API integration. Next threat intelligence platform is malware information sharing platform, that is MISP. So it is open source threat intelligence platform designed for sharing structured threat data. It is developed by CIRCL, that is Computer Incident Response Center in Luxembourg, and it is available at misp-project.org. It is a self-hosted deployment. And analyst use cases include to share indicator of compromises with trusted partner organizations, to receive threat intelligence from ISACs, that is Information Sharing and Analysis Centers, to automate integration of compromise ingestion into SIEM via API, and to investigate relationships between threat actors and malware campaigns. Next is Open Cyber Threat Intelligence, that is OpenCTI. So this open source threat intelligence platform is developed by ANSSI, that is French National Security Agency. It is available at opencti.io, self-hosted or cloud deployment, and it is focused on structured graph-based threat intelligence with rich relationship mapping. So some analyst use cases for the OpenCTI. It can be used to build comprehensive threat actor profiles, visualize attack campaign relationships, track which CVEs are being actively exploited, and feed structured threat intelligence into SIEM and SOAR platforms. So CVE, I hope you know, are the common vulnerability and exposures. There is a database of these vulnerabilities, and so this OpenCTI can track which CVEs are exploited. Next is endpoint security. So endpoint detection and response, that is EDR, which monitors and responds to threats at the endpoint level. Core capabilities of EDR include continuous endpoint monitoring and telemetry collection, real-time threat detection using behavioral analysis, automated response, that is to isolate host, kill the process, and quarantine file, threat hunting, which is query the endpoint telemetry across all devices, and root cause analysis, that is to reconstruct full attack chain from initial access to impact. So these are the some capabilities of the EDR, that is endpoint detection and response. So next is extended detection and response, XDR, which correlates data across not only endpoints but endpoints, network, cloud, and email. So XDR extends coverage to endpoints plus network plus emails plus cloud and identity. It correlates data across all layers for unified threat detection. It reduces alert fatigue by linking related events into single incident and provides end-to-end attack visibility across entire kill chain. So these are some of the differences between the EDR and XDR. So both are part of the endpoint security. So with respect to coverage, and EDR is for endpoint only, while XDR is multi-layer, that includes endpoint, network, cloud, and email. Correlation of EDR is endpoint centric, while XDR gives us cross-domain correlation. Alert volume in EDR is higher, while in XDR there are lower and consolidated alerts. Visibility of EDR is deep endpoint telemetry, while the XDR provides broad cross-environment visibility. Next is the MDM in endpoint security. So MDM, mobile device management, manages and secures mobile devices across the organization. It extends endpoint security controls to the mobile devices such as smartphones and tablets, and it is critical as mobile devices accesses corporate email, data, and applications. So security capabilities that are relevant to analysts are device compliance monitoring. So MDM identifies not compliant or jailbroken devices. Remote wipe, using MDM we can erase device if it is lost, stolen, or compromised. App management controls which application can be installed, or it can control the installed application and also block unauthorized application. And certificate deployment, so we can push security certificates for VPN and Wi-Fi authentication to these mobile endpoints. Next is domain and IP reputation. So first one is who is. So who is a protocol and a database that stores registration information for domain names and IP addresses. It is publicly accessible and provides ownership and registration details. So what are some security capabilities that are relevant to the analyst of this who is protocols? So these include the domain registrant name, organization, and email address, registration date and expiration date, name server and DNS configuration, registrar information, IP address assignment, and ASN, that is autonomous system number. So Abuse IP DB is a free community-driven database of IP addresses reported for malicious activity. It is available at abuseipdb.com. It provides crowdsourced reports from security professionals and automated systems worldwide. So some abuse categories include port scanning, SSH brute force, and file transfer protocol brute force. Web application attacks like SQL injection and cross-site scripting, spam and phishing source DDoS attack participation, and malware command and control server. Geolocation by IP, GeoIP. So GeoIP maps IP addresses to geographic locations. It provides country, region, city, internet service provider, and ASN information for an IP address. So some analyst use cases include GeoIP is an approximation and not perfectly accurate. Attacker use VPN, Tor, and proxy chains to mask true location. Cloud provider IPs such as AWS, Azure, and GCP resolve to data center locations, not user location, and use as one indicator among many, not a definitive conclusion. So now coming over to some file analysis tools. So first one is strings. So strings is a command line tool that extracts human readable text from binary files. It is pre-installed on Linux and available for Windows via sys internals. It is one of the first steps in static malware analysis. So why strings analysis matters? So malware often contains readable artifacts such as URL, IP addresses, registry keys, and error messages. So it reveals attacker infrastructure embedded in malware samples. It identifies capabilities, that is file paths suggest what malware targets, and no execution is required, so it is safe static analysis technique. Next is VirusTotal. So it is a free online multi-engine malware analysis platform which is owned by Google. It is available at virustotal.com. It scans files, URLs, domains, and IP addresses against 70 plus antivirus engines simultaneously. So some key features of VirusTotal include file scanning. So you can upload file for analysis against all antivirus engines. Hash lookup. So it is hash or search by MD5, SHA-1, or SHA-256 without uploading file. URL and domain analysis. So it checks for URLs and domains for malicious content. Behavior analysis. So dynamic analysis, sandbox results. Community comments. So analysts can comment and there. So analyst notes and observation can be seen on this virustotal.com. And relations graph. So it visualizes connection between files, IP addresses, and domains. So next is Yara. So Yara is a pattern matching tool used to identify and classify malware. Full name of Yara is yet another recursive acronym. It was created by Victor Alvarez at VirusTotal, and it is considered the Swiss Army knife of malware research. So how Yara works? So analyst writes rules describing characteristics of malware. Yara scan files, memory, or network traffic for matches and returns match if file contains the defined pattern. So common analyst use cases include to scan endpoints for known malware family indicators, hunt for specific malware across enterprise using EDR integration, identify malware variants sharing code with known samples, and detect web shares on web servers. Next is sandboxing. So sandboxing executes suspicious files in an isolated and controlled environment. You can safely observe malware behavior without risk to the production environment and systems, and it captures dynamic behavior that static analysis tools cannot reveal. So what does the sandbox captures? Network connection made by the malware, files created, modified or deleted, registry keys added or modified, processes spawned and injected into, system calls and API usage, screenshots of malware execution, and DNS queries and HTTP requests. So some sandboxes example, first one is Joe Sandbox. So it is a commercial sandbox platform with free community tier. It is available at joesandbox.com. It is known for extremely detailed and comprehensive analysis reports. So some key features of Joe Sandbox include multi-OS support. So it supports Windows, Linux, macOS, Android, and iOS analysis. Hypervisor level analysis, so it detects sandbox aware malware that tries to evade detection. Full behavior reports, network, file system, registry, process, and screenshot analysis. MITRE attack mapping, so it maps observed behavior to MITRE platform or MITRE attack techniques automatically. Yara and Sigma rules, so it auto-generates detection rules from analysis. So some analyst use cases for Joe Sandbox. So you can submit suspicious email attachment for safe analysis. It can analyze malware sample from incident response engagement. It can generate indicator of compromises from malware behavior for seam blocking rules and validate threat intelligence reports against real-time malware samples. Next is the Cuckoo Sandbox. So it is most widely deployed open source automated malware analysis sandbox. It is self-hosted, so organization controls data and there is no external sharing, and it is available at cuckoosandbox.org. Key features of Cuckoo Sandbox include that it is free and open source, so you have full control over deployment and data. It has modular architecture, so it extends with custom analysis module. Multiple VM support, so it can analyze against different Windows and Linux configuration. Network analysis, so it captures and analyzes all network traffic during execution. Memory analysis, so it integrates with volatility for memory forensic. And web interface, so it has easy submission and report viewing. So difference between the Joe and Cuckoo Sandbox. So with respect to cost, Joe Sandbox is commercial, but it has a free tier as well. Cuckoo Sandbox is free and open source. With respect to deployment, Joe Sandbox is cloud-based, while Cuckoo is self-hosted on-prem. Evasion resistance of Joe Sandbox is high, while for Cuckoo it is moderate. Setup complexity for Joe Sandbox is none since it is cloud-based, while for Cuckoo it is of course high since the customer has to deploy it in its own infrastructure. Data privacy in Joe Sandbox, it is external since it is cloud-based, while in Cuckoo the data resides inside your internal network, and report depth in Joe Sandbox is very detailed, while in Cuckoo it is good. Next is the pattern recognition that with regex or regular expressions. So regular expressions are patterns used to match, search and extract text. So these are fundamental skills for log analysis, threat hunting and SIEM rule writing. And regex is used across SIEM platforms such as Splunk, grep, Python and security tools. Examples include to find email addresses, IP addresses, file names and log entries. Some analyst use cases include SIEM searches, log analysis, and threat hunting. So, next is the pattern recognition, interpreting suspicious commands. So, analysts must recognize malicious command patterns in logs, EDR, telemetry, and SIEM alerts. So, attackers use built-in OS commands to avoid detection. So, LOL-bin's knowledge is essential. Next is email analysis, that is MX Toolbox. So, it is free online email and DNS diagnostic platform. It is available at mxtoolbox.com. It is essential tool for email header analysis and domain email security investigation. So, business email compromise investigation workflow with MX Toolbox can be done. You need to extract full email headers from suspicious email, paste it into MX Toolbox header analyzer, identify true originating IP address, check originating IP address IP against abuse IPDB, verify SPF, DKIM and DMARC results, check sender domain registration date via whois, and confirm findings and escalate. Next is user and entity behavior analytics, that is UEBA. So, UEBA analyzes patterns for behavior of users and entity, that is devices, applications and services. It establishes behavioral baselines and alerts on significant deviation. It goes beyond rule-based detection, so it uses machine learning to identify anomalies. So, how user and entity behavior analytic works? So, it collects data from SIEM, Active Directory, HR systems, data loss prevention, and endpoint tools. It builds behavioral baseline for each user and entity over time. It assigns risk scores to users and entities based on observed behavior and alerts when behavior deviates significantly from established baseline. Open UBA. So, open source UBA platform is community driven alternative to commercial solution. It is available at openuba.org. It is built on open source stack, that is Elasticsearch, Logstash and Kibana, known as ELK. And key features include behavioral analysis, behavioral baseline modeling for users and entities, pre-built analytics for common insider threats and account compromise scenarios, integration with standard log sources, Active Directory, Windows event logs and proxy logs, customizable detection models, tailor analytics to organizational baseline, dashboard and virtualization layer for analyst workflow. So, our next topic is file formats. So, security analysts encounter multiple data formats when analyzing logs, threat intelligence feeds, configuration files, and security tool outputs. Understanding how to read and parse these formats is essential for effective log analysis, SIEM ingestion, and automation scripting. So, JSON is JavaScript object notation. So, it is lightweight, human readable data interchange format. It is most widely used format in modern security tools, APIs and log output, and native output format for Suricata, EVE logs, Zeek logs, Cloud Audit logs and REST APIs. So, some file formats, first one is XML. So, it is tag based markup language for structured data representations. It is older format but still widely used in enterprise security tools and Windows event logs. It is more verbose than JSON but supports complex hierarchical data structures. So, security tools that use XML. So, window event logs are native XML format underneath EVTX. NetApp and Nmap So vulnerability and scan reports of these tools are in XML format. SIEM import, so many SIEMs accept XML formatted log feeds. SAML authentication, so SSO, that is single sign-on assertions, use XML formats. And SNOT rules, so some rules export formats use XML. Next is YAML, that is YAML and markup language. So it is human readable data serialization format. It is commonly used for configuration files and security tool rule definitions, and it is more readable than JSON and XML, that is minimal syntax indentation based structure. So security tool YAML usage, so Sigma rules, vendor neutral SIEM detection rules are written in YAML. Ansible playbooks, so security automation and configuration management, these are also written in YAML. Kubernetes manifest, so container security policy definition. Docker compose container deployment configuration files, and GitHub Actions security pipeline automation workflow. So these are tools use YAML. Next is EVTX, which is Windows Event Log format. So it is binary log format used by Windows Vista and later for storing Windows event logs. It replaces older .evt format and it is more structured and efficient. It contains all Windows security system and application events. So tools for EVTX analysis, first one is Windows Event Viewer. So it is built-in GUI for browsing event logs. PowerShell get when event, so it can be used to query and filter events via command line. CySA is fast EVTX hunting tool using Sigma rules. EVTX ECMD, it is Eric Zimmerman's EVTX parser and it exports to CSV and JSON. And Hayabusa is window events log, fast forensics and threat hunting. Now coming over to programming and scripting languages. So analysts are not expected to be software developers, but they should understand how scripts are used for automation, investigation and attacks. So Python is most widely used programming language in cybersecurity. It is versatile and used for automation, log parsing, malware analysis, tool development and API interaction. It has a rich ecosystem of security-focused libraries. So why Python for security analysts? So it is simple and has readable syntax. So it has low barrier to entry, extensive standard library, file handling, networking and regex are built in. It has rich third-party security libraries. It can be used cross-platform. It runs on Windows, Linux and Mac OS. And it is dominant language for SIEM automation and SOAR playbooks. Next is PowerShell. So it is Microsoft's task automation and configuration management framework. It is built into all modern Windows system and no separate installation is required. It is essential for Windows incident response, log analysis and security automation. So why PowerShell is necessary for security analysts? So it has deep integration with Windows. It gives access to event logs, registry, Active Directory and WMI. It has pipe-based command chaining. You can chain commandlets for powerful one-liners. Remoting, so it can execute commands on remote systems during incident response. And it can be used by both attackers and for both attacker and defender too. So analysts must understand both use cases. Shell scripting. So shell scripts automate tasks in Linux and Unix environments using command line interpreters. So primary shells, that is bash, is most common. Similarly, we have shell, Z shell and fish. These are essential for Linux-based security tools, log analysis, and incident response automation. So why shell scripting is important for security analysts? So Linux dominates server infrastructure, so most security tools run on Linux. It automates repetitive log analysis tasks. It can chain multiple security tools together in automated pipelines. It is essential for DFIR, that is digital forensic and incident response on Linux system. And it is lightweight and requires no additional runtime or libraries. Objective 1.4, explain threat intelligence and threat hunting concepts. So what is threat intelligence and threat hunting? Threat intelligence is knowledge about existing or emerging threats, including actors, TTPs, and IOCs. TTPs is tactics, techniques, and processes, and IOC is indicator of compromises. Threat hunting is proactive search for threats that have bypassed preventive controls. That is, it assumes breach, that the breach has already taken place. And the goal is to move from reactive to proactive security using intelligence-driven defense. So what are the threat actors? So threat actors may be advanced persistent threat, that is APTs. So these are highly skilled, well-funded groups, often nation-state sponsored. They maintain long-term access. They are stealthy and focused on espionage or sabotage. Example of some APTs include APT-28, also known as Fancyware, and APT-41. So some APT characteristics are that they are advanced, they use custom malware, zero-day exploits, and sophisticated techniques. They are persistent, so they maintain long-term access, sometimes for years, without detection. And their approach is targeted, so they have specific objectives, and these may be espionage, intellectual property theft, sabotage, or financial gain. Next is the insider threat. So these are malicious or negligent internal employees and contractors, and they can cause significant damage due to legitimate access to system and network. Insider threat indicators include accessing data outside normal job function and normal job hours, downloading unusually large volumes of data, attempting to access systems beyond authorization, working odd hours with no business justification, expressing dissatisfaction or planning to leave organization, disabling security tools or clearing audit logs, and connecting unauthorized storage devices. So next is tactics, techniques, and procedures, that is TTPs. So TTPs describe the behavior and methods used by threat actors. They are most valuable intelligence for defenders, harder to change than IOCs, that is indicator of compromises. So TTP hierarchy is, we have tactics. So these are high level goals or objectives, for example, initial access, persistence, or exfiltration. Techniques are the specific methods used to achieve tactics, that is spear phishing, registry run keys, and procedures are specific implementation details of techniques such as exact commands, tools, and scripts used. Heat maps are visual representation of threat activity frequency and intensity across an environment, and they use color gradients to show concentration of threats, attacks, or vulnerabilities. So analyst values for heat maps and TTP are to quickly identify highest risk areas that require immediate attention, to prioritize remediation effort based on attack concentration, communicate security posture to management visually, track changes in attack pattern over time, identify blind spots, areas with no coverage or visibility. Next is a pyramid of pain. So it is framework created by David Bianco describing the relative difficulty of using different indicator of compromise type. And higher on the pyramid means more painful for attacker when defender detects and blocks it. So it guides analysts on where to focus detection efforts for maximum impact. So key takeaways for analysts are that most security teams focus on hashes and IPs, which are lowest value and easiest for attacker to change. So the shift should focus to detecting TTPs and tools for durable and high value impact detection. So as we can see these areas, so this is the pyramid of pain. So the higher we go, the more the pain. So we should focus our tools on these high value targets rather than on hash value or IP addresses. So MITRE ATT&CK framework is a globally accessible knowledge base of adversary tactics and techniques. It is based on real-world observation of threat actor behavior. It is available at attack.mitre.org and it is used by defender worldwide for threat modeling, detection engineering and gap analysis. So why analysts use it? So analysts use it for threat hunting, incident response, threat intelligence and security assessments. So the MITRE ATT&CK framework or structure include 14 tactics. This is the why means the adversary goals, techniques are the how. These are the methods used by adversary to achieve goal. Sub-techniques are specific variations of technique and procedures are real-world implementations by specific threat actors. The attribution is the process of identifying the threat actor responsible for an attack. It is one of the most challenging aspects of the threat intelligence and it requires correlation of technical, operational and strategic intelligence. So attribution indicators include technical, these are malware code similarities, reused infrastructure and TTPs matching known groups. Next is operational, these are attack timing, business hours in specific time zones, target selection patterns. Next is strategic, so geopolitical context, victims aligned with nation-state interest. And last one is linguistic, which is language artifacts in malware code, error messages or C2 communications. Confidence level impacts. So first one is timeliness. So threat intelligence loses value rapidly if not delivered and acted upon quickly. So time-sensitive intelligence must reach the right analyst before the threat windows closes. So impact of poor timeliness is that indicators are blocked after attacker already achieved the objectives, defenders acting on outdated infrastructure that attacker abandoned, missed detection windows for active intrusion and intelligence sharing delays reduce collective defense effectiveness. Relevance is intelligence is only valuable if it applies to your specific environment, industry or threat profile. It is irrelevant. So irrelevant intelligence creates noise and alert fatigue. So building relevance filters is to profile your organization's threat landscape, that is industry, geography and technology. Subscribe to sector-specific threat intelligence, that is ISACs. Tag intelligence feeds by relevance category and score incoming intelligence against your environment profile before actioning. Next is accuracy. So inaccurate threat intelligence is worse than no intelligence. It drives incorrect defensive actions, false positive waste analyst time and damage trust in intelligence program. So impact of inaccurate intelligence is blocking legitimate IP addresses, causing business disruption, wasting investigation time on false positive alerts, missing real threats while chasing inaccurate indicators, and eroding confidence in threat intelligence program among stakeholders. So intelligence collection methods and sources, and the first one is OSINT, that is open source intelligence. So OSINT is intelligence gathered from publicly available resources. It is free to collect and requires skill to analyze and contextualize. It is widely used for threat actor research, attack surface discovery, and indicator of compromise enrichment. So some key OSINT tools include Shodan. So Shodan is a search engine for internet connected devices and services. Next is Maltego, which is a visual link analysis and OSINT investigation platform. The Harvester gathers emails, domains, IPs from public sources. Recon-NG is a modular web reconnaissance framework, and Spiderfoot is automated OSINT collection platform. So what are some closed source intelligence platform, and what is the closed source intelligence? So closed source intelligence is also known as proprietary or commercial threat intelligence. It is collected through non-public channels, and it requires purchase, partnership, or privileged access. So the closed source intelligence over OSINT include that closed source intelligence is of higher quality and contains more thoroughly vetted data. So closed source intelligence access is not publicly available. It has a dedicated analyst teams curating and contextualizing data, and it has faster time to intelligence for emerging threat and direct researchers relationship for clarification. So if you purchase this closed source intelligence, you may have direct researcher relationship for clarification. Next is threat intelligence sharing. So sharing threat intelligence amplifies the defensive value. What one organization discovers protect all the organization if it is shared with all other organizations. And formalized sharing uses standard formats and protocols. So the information that is shared through threat intelligence include malicious, let's suppose malware or malicious information, IPs, domain names, hashes, TTPs, and threat actor information. Next is the indicator of compromise, IOC. So IOCs are artifacts observed on a network or system that indicate a potential intrusion. So it is digital forensic evidence that a security incident has occurred or is in progress. So the IOC provides digital forensic evidence about a potential security incident that has either occurred or is in progress, and it can be used to detect, investigate, and respond to threats. IOC life cycle include the first phase is of course the collection. So gather IOCs from incidents, threat feeds, and intelligence sources. Next is analysis. It is to validate, enrich, and contextualize raw IOCs. Next is application of IOC, to deploy IOCs into security tools for detection and blocking, and then review to monitor effectiveness and retire aged or inaccurate IOCs. So the IOC collection, IOCs are collected from multiple sources. They may be internal or external. So internal collection sources include incident response investigations, malware analysis produces hashes, IPs, and domains, SIEM alerts, so suspicious events reveal potential IOCs, endpoint detection and response telemetry, so endpoint activity logs reveal malicious artifacts, firewall and proxy logs, so these identify suspicious connections, and email security gateways extract IOCs from phishing campaigns. Next is external collection sources. So these include threat intelligence platforms such as OTX, MESP or OpenCTI that we already studied in our previous slides, commercial threat feeds, ISAC sharing communities, government advisories such as CISA alerts, FBI flash reports, open source malware repositories that is Malware Bazaar, and security vendor research blogs and reports. Next is the IOC analysis. So raw IOCs required validation and enrichment before operational use. Poor analysis leads to false positive and wasted analyst time. Next is IOC application and usage. So validated IOCs must be operationalized into security controls to provide defensive value. So we have mainly two types of IOCs. First one is the atomic indicators. So atomic IOCs are the simplest, most specific indicators. They cannot be broken down further. They are easy to collect and deploy but lowest on the pyramid of pain. So they are trivial for attackers to change. It means that attackers can easily change them if they are collected by the defensive teams. So what are the limitations of atomic IOCs? So they have short lifespan, attackers rotate IP addresses and domain rapidly, high false positive risk. So shared IPs, CDNs and cloud providers used by both malicious and legitimate traffic. It has no context, so a hash value alone does not explain what malware does or why it is dangerous. Next is the behavioral indicators. So behavioral IOCs describe pattern of activity rather than specific artifacts. They are higher on the pyramids of pain and much harder for attackers to change, and this type of IOC forms the basis of advanced threat detection and hunting. So a comparison between behavioral and atomic IOCs. So the aspects include specificity. So atomic is very specific while behavioral is pattern based. Attackers effort to evade. So in atomic, the attackers require minimal effort to evade, while in behavioral, the attackers need significant effort to evade. Detection durability of atomic is short-lived, while behavioral is long-lasting, and false positive rate of atomic IOC can be very high, while it is lower with tuning for behavioral. And detection method for atomic is blacklist matching, while for behavioral, it is behavioral analytics and SIEM rules. So our next topic is threat modeling. So threat modeling is a structured process to identify, assess and prioritize potential threats. So it is performed during system design or security assessment, and it assesses what can go wrong, how likely is it, and what we do about it. So some threat modeling models you can say. First one is STRIDE. So STRIDE is a threat categorization framework developed by Microsoft. It is used to systematically identify threats against systems and applications. So STRIDE basically stands for each of these letter in STRIDE stand for S for spoofing, T for tampering, R for repudiation, I for information disclosure, D for denial of service, and E for elevation of privileges. So what are the security property violated by each of these threats? So spoofing violates the authentication, and an example is attacker impersonates as a legitimate user. Tampering violates the integrity, so attacker modifies data in transit or data at rest. So security property by repudiation that is violated is non-repudiation. For example, user denies performing an action with no audit trail. Information disclosure basically violates confidentiality. For example, sensitive data exposed to unauthorized parties. Denial of service violates availability, so system is made unavailable to legitimate users through denial of service. Elevation of privileges violates the security property of authorization. So in this violation, user gains higher privileges than they are authorized. Next is threat mapping. So threat mapping connects identified threats to your specific environments, assets, and controls, and it links threat intelligence to defensive architecture decisions and bridges the gap between abstract threat data and concrete security actions. So threat mapping process include identifying assets, so what you are protecting, data, system, and infrastructure. First, these must be identified. Next is to profile threat actors, so who is likely to target you based on industry and geography. Next is map TTPs, so which attack techniques does this actor use. Then the assess coverage, so do you have detections for these techniques, and last is to identify gaps, which are techniques with no detection or prevention. Our next topic is cyber deception. So cyber deception uses deliberate false information and decoy resources to mislead attackers. It detects threat earlier in the attack life cycle, often before real damage occurs, shifts the advantage to defender. Attacker wastes time on fake assets. So cyber deception can be done through honeypots and honeynets, decoy credentials and files, fake systems or data, and moving target defense. Objective 1.5 explain the importance of efficiency and process improvement in security operations. So what is process improvement and efficiency? So modern security operations centers face an ever increasing volume of alerts, threats, and data. Manual processes cannot scale, so analysts suffer alert fatigue and burnout. So process improvement transforms a reactive security operations center into a proactive, efficient security operation. So there are three pillars of SOC efficiency, and these include: first one is standardize, which is consistent, repeatable processes. Streamline is to automate and enrich to reduce the manual effort, and integrate connects tools to eliminate silos and manual handoffs. So what are standardized processes? So standardization ensures that every analyst responds to threats the same way every time. It eliminates inconsistency, reduces human error, and enables measurable improvement. And it is a foundation of a mature security operation program. Key practices of standardization include to develop and maintain playbooks, which are step-by-step guides for common scenarios, to develop runbooks, which are detailed technical procedures for specific tasks, and document escalation procedures and roles/responsibilities. A real-world impact of standardization is that standardization incident response playbook reduces response time from hours to minutes. Streamline operations goal is to eliminate manual repetitive tasks and improve overall security operations center efficiency. So automation and orchestration is to develop and maintain playbooks, which are step-by-step guides for common scenarios, develop runbooks, which are detailed technical procedures for specific tasks, and document escalation procedures and roles and responsibilities. Streamline operation through SOAR, that is security orchestration and automation response. So SOAR is security orchestration, automation, and response. It is a platform that connects security tools, automates repetitive tasks, and orchestrates response workflow. It addresses the core SOC challenge, that is too many alerts and too few analysts. So SOAR benefits include reduce mean time to recover from hours to minutes. For common incident types, it handles 10 times more alerts with same analyst head count. It has consistent response, so automation never skips steps, and analysts' focus shifts to complex investigations requiring human judgment. So a SOAR playbook example, for example, a phishing response. So email is flagged by the security gateway, which is triggered by SOAR, or SOAR is triggered. So SOAR automatically extracts IOCs from email, that is the sender, URLs and attachments. It checks the IOCs against VirusTotal, OTX, abuse, IPDB simultaneously. If the IOCs are malicious, it automatically blocks the sender domain in email gateway. It searches the same for other users who received same email. Create incident ticket with all findings pre-populated. Notify the affected user automatically and assign to analyst for final review and closure. So automation and orchestration, that is infrastructure as a code, IAC. So infrastructure as a code manages and provisions infrastructure through machine readable configuration files. Infrastructure defined in code, so version controlled, repeatable and auditable. It transforms manual infrastructure setup into automated, consistent deployments. IAC security scanning to identify misconfigurations before infrastructure is deployed. Check for open security groups, unencrypted storage and excessive identity and access management permission. Tools include CheckOV, TerraScan, TFSec and AWS Cloud Formation Guard. Next is data enrichment. So data enrichment automatically adds context to raw security alerts and events. It transforms a bare IP address or hash into a rich, actionable intelligence artifact, and it dramatically reduces the investigation time. So context provided before analyst begins work. So some enrichment data sources include threat intelligence platforms such as OTX, MISP, VirusTotal and Abuse IPDB, GeoIP datasets, that is geographic location of IPs, WHOIS data, which is domain registration information, asset inventory, internal system ownership and criticality. HR systems include the user identity, role, department and employment status. Vulnerability scanners for known vulnerabilities on affected hosts. So we already went through this. The rules and alert tuning. So alert tuning reduces false positive and false negatives to improve detection quality. So poorly tuned rules create alert fatigue, that is analysts ignore alerts and real threats are missed. Continuous tuning is essential, so environment and threats constantly evolve. So tuning process is number 1 to identify highest false positive rules, number 2 to analyze root cause of false positive, number 3 is to add targeted exceptions without breaking detection logic, number 4 is to test in shadow mode before production, and number 5 is to monitor and document all changes. Next is in data enrichment is dashboard creation. So dashboards provide real-time situational awareness for different audiences. So dashboards provide real-time situational awareness for different audiences. So this sentence is of course repeated. So best practices are to maintain maximum 6 to 8 widgets per dashboard, such as here we can see we have 6 widgets. Consistent color coding, that is red, amber and green, and to show trends, not just current state. auto refresh for operational dashboards, and separate views for analyst, manager, and CISO audiences. Our next topic is technology and tool integration. So, siloed tools slow down operations. Integration creates a unified security ecosystem. So, key integration methods include through APIs. So, APIs allow tools to communicate programmatically, that is, SIEM pulling data from EDR. Webhooks, so real-time event notification, for example, alerts from one tool trigger action in another. Plugins and connectors, so pre-built integrations, for example, Microsoft Sentinel connectors and Splunk add-ons. So benefits include single pane of glass for analysts, faster data correlation, and automated cross-tool workflows. So our last objective of domain 1, objective 1.6, is to summarize concepts related to the use of AI in security operations. So AI in security operations, so use of artificial intelligence, that is machine learning, generative AI, etc., to enhance detection, analysis, response, and automation in security operations. Benefit of using AI is faster analysis, better pattern recognition, reduced manual workload, and improved threat detection. Some challenges with AI include new risks introduced by AI itself, which requires careful governance. So some risks introduced by AI, first one is hallucination. So AI models sometimes generate confident but completely fabricated information. These are called hallucinations. Model produces plausible sounding but inaccurate output. And they are particularly dangerous in security operations where accuracy is critical. Security impact of hallucination is that AI recommends incorrect remediation steps during incident response. AI generates false IOCs that waste analyst investigation time. AI misidentifies benign activity as malicious or vice versa. And AI produces fabricated CVE details or threat vector attribution. The next AI risk is data exposure. So AI tools process data submitted to them, creating risk of sensitive data leaving the organization. So analysts may unknowingly submit confidential data to external AI platforms. Exposure scenarios include analysts paste customer personally identifiable information into public AI chatbot for log analysis. So proprietary source code submitted to AI coding assistant, incident details including unreleased vulnerability information shared externally, and AI training on organizational data exposes sensitive information to other users. Next AI risk is the model poisoning. So model poisoning attacks manipulate AI model training data to corrupt the output. So attackers influence what the AI learns, causing it to make incorrect decisions. Security impact of model poisoning is that compromised AI detection model misses real threats systematically. Attacker knows which techniques will evade AI-based detection. Poisoned threat intelligence models provide inaccurate risk assessments. Mitigation includes to validate the training data sources, use trusted and verified data sets, to monitor model performance over time. Sudden accuracy drops may indicate the model poisoning, and to implement model integrity checks. Next risk is the malicious prompts. So attackers craft input designed to manipulate AI systems into unintended behavior. So there are two primary attack types. First one is the prompt injection, and next is the jailbreaking. So in prompt injection, attackers embeds malicious instructions within data processed by the AI. AI follows attacker instruction instead of legitimate user instruction. An example is malicious email contains hidden text instructing AI email assistant to forward all emails to the attacker. Next one is the jailbreaking, which is crafting inputs that bypass AI safety restrictions and guardrails. It tricks AI into generating harmful content or ignoring security policies. Example is framing malicious request as fictional scenario to bypass the content filters. Next AI risk is malicious prompts. So malicious prompt security impacts include AI security tools manipulated to ignore specific threats, AI assistants leaking sensitive information via crafted queries, and AI-powered automation executing unintended actions. Mitigation includes to use input validation and sanitization for AI processed data, privilege separation, so AI operates with minimum required permission to monitor AI inputs and outputs for anomalous patterns, and regular adversarial testing for AI security tools. Now coming over to AI governance, that is legal and regulatory compliance. So AI usage in security operations must comply with applicable laws and regulations. Regulatory landscape for AI is rapidly evolving globally. So specific compliance requirements include data residency. So AI processing may move data across borders, violating data sovereignty laws. Explainability. So some regulations require ability to explain automated decisions. Bias and fairness. So AI decisions must not discriminate unlawfully. Human oversight. So here high-risk AI decisions may require human review before action, and audit trails, so documented AI assisted decisions for regulatory review. AI usage policies include, so organization must define clear policies governing how AI tools are used in security operations. Policies protect the organization from AI related risks while enabling productive AI usage. AI usage policies include to define what data can be and cannot be sent to AI tools, require human oversight for critical decisions, classify AI tools, internal versus external and approved versus unapproved, and audit AI decisions and maintain accountability. So some AI use cases include comparing artifacts, so quickly compare malware samples, file versions or configurations, analyzing log files to identify anomalies, summarize large log volumes and detect patterns, document creation, so auto-generate incident reports, playbooks or summaries, incident investigation, assist in timeline creation, root cause analysis and hypothesis generation, event correlation, so link related alerts across SIEM, EDR and network tools more effectively, and automation and orchestration, so power, SOAR, playbooks, auto enrichment of alerts and intelligent response actions. So key takeaways include, so AI has certain advantages which include significantly improved speed, scale and accuracy in security operation center operations. Major risks include hallucinations, data exposure, model poisoning and prompt injection. So governance of AI is critical, so always combine AI with human oversight and strong policies. And a balanced approach is needed, which is to use AI to augment analysts, not replace them. So that's all for this domain number 1. So this domain was considerably long, so that's why I went through very fast through the slides so that I can reduce the overall time of this video. So I hope this has been informative. So please like and subscribe for the upcoming videos. See you soon. So welcome back to our CompTIA CySA Plus course. and in this video we will go through domain 2, that is vulnerability management. And our first objective 2.1 is, given a scenario, implement the appropriate vulnerability scanning method. And our very first topic is vulnerability scanning. So what is a vulnerability scanning? Vulnerability scanning is the automated process of identifying security weaknesses, misconfigurations, and missing pages in systems, applications, and network devices. So it is a process to identify misconfiguration, weaknesses, missing security pages that can be exploited by malicious actors, and we do scan the endpoint devices, the servers, mobile devices, cloud, application, all our assets for these security flaws and weaknesses. So the purpose is to, of course, identify the vulnerabilities in this system, and then once identified, prioritize these vulnerabilities according to their criticality and sensitivity, reduce the attack surface. So once you remediate these vulnerabilities, the attack surface is reduced, and there may be some laws or regulations that require regular scanning of these systems, so to support compliance requirements. So why does the vulnerability scanning matter? So organization cannot protect assets they do not know exist, or vulnerabilities they have not yet discovered. So if you haven't, or the organization haven't discovered the vulnerabilities, they cannot protect them. So the vulnerability scanning is the first step, you can say, to patch or remediate, or you can say to protect your assets. So once you identify these vulnerabilities, then you can protect your assets. So for protection of these assets, vulnerability scanning is very important. And the foundation of vulnerability scanning is, of course, asset inventory. So you cannot secure what you do not know exists. So if you do not know that you have, let's suppose, X number of servers, Y number of application, and Z number of end devices, then of course you cannot protect them. So the very first and foundation step is to have accurate and complete inventory of your assets. So a robust asset inventory is the prerequisite for any scanning program, and these assets may be hardware and software assets. They may be also divided as per the criticality and data sensitivity, and as per the owner accountability. So for example, the host or the servers, their owner may be, let's suppose, a custodian or a system administrator. The network printers and the network routers, their owner, or you can say their custodian, may be network administrator. So you can also list the inventory as per the owner, as per their owners. Next is the planning scope. So establishing the rules of engagement for scanning prevents operational disruption and ensures relevance. So you cannot just go and just blast the scanning without any first implementing the rules of, or determining the rules of engagement. So these rules of engagement may be to define the scanning boundary. For example, you may say that we must not scan the very critical production system because there are chances of service disruption. So you can delay these scannings for later time when there is a maintenance window. Then before scanning, you must communicate with the stakeholder. For example, there may be services that are shared with other stakeholders, so you must take them in confidence. You must communication the scanning to them so that they are not taken by surprise when the scanning occurs and there are some disruption or some logs generated by the scanning, and then some technical constraint that may be need to taken into consideration before starting the scanning. Next is the scheduling and operation. So scheduling is the balanced frequency of these scans. So scans must be regular. They may be weekly or monthly, or they may be trigger based. For example, if there are, you can say there were some security pages released by the vendor and the systems are patched. So now you can scan the system to identify that whether the patches are correctly applied. Next is the operation. So the scans may be aligned with the maintenance windows to ensure that scanners do not conflict with the critical task. As I said, the scanning may disrupt critical services, so we may need to align the scanning schedule with the maintenance windows. And of course the performance, so managing the bandwidth and CPU usage, so throttling is necessary for legacy systems. So scanning is very, you can say, resource intensive activity, so you may consider throttling or slowing down the scanning speed for certain systems that are maybe, let's suppose, legacy or that are fragile. For example, legacy OT system, you may throttle the scanning process for these systems to prevent the crashing or disruption of these critical systems. Next is the sensitivity and compliance. So sensitivity is determining the deep scan versus light scan based on how fragile a target system is. For example, as I said, the operational technology or the industrial control system, they are very critical and very fragile system because they are mostly legacy systems. So you need to have the throttled or light scan when planning to scan these systems. Another consideration is the segmentation. So ensuring scanners can reach segmented VLANs or air gap zones via jump boxes. So if you, let's suppose, you start the scanning, let's suppose, from a laptop, and let's suppose there are some servers inside network, let's suppose they may be in VLAN 100, and there are other systems that, let's suppose, maybe in VLAN 200. So if your laptop is connected to VLAN 100, the scanning may not reach the VLAN 200. So you must keep these things in mind, that the network segmentation and the air gap zones all are catered for, and the scans or the scanning packers or the scanning systems can reach all these segmented and air gapped networks. Regulatory is ensuring the scan frequency and reporting meet specific regulatory requirements, such as this may be HIPAA, PCI DSS or GDPR requirements. So if PCI DSS requires that scanning must be done quarterly, you cannot delay it for annual or for biannual. You must do it quarterly as per the regulatory requirement. Visualizing the asset inventory. So a modern vulnerability management platform relies on real-time visualization of the network state. So what does this mean? That the modern vulnerability scanner and management platform relies on the visualization and availability of asset inventory. So if they have the visibility of the asset inventory, then you can start the scanning and further process. So visibility is unified view of cloud and on-prem assets. Context is mapping vulnerabilities to business impact. Again, seeing these systems, you can then map the vulnerabilities to business impact. So for example, if there are some critical vulnerabilities, then you can say, you can map that how these vulnerabilities impact the business if these are exploited. Dynamic is automated updates as new devices join the network. So for example, if new devices join the network, then the system must dynamically update the inventory so that the visibility is complete. Next is the internal versus the external scan. So what is the internal scan? So internal scan is run from within the network perimeter. For example, this one. So this scan is being run from within the, if this line is the network perimeter of the organization, so the scan is run from within the organization network. And this identifies a malicious insider or a compromised device could see and exploit. So this scenario, the internal scan basically validates an insider threat. So for example, if the internal scan can see vulnerabilities or can see or can you can say exploit devices, it means that a malicious insider can also do the same. So this scan basically caters for insider threat, and the focus is on lateral movement. Lateral movement means that, let's suppose, if one system is compromised, the scanning shows that whether the compromise or the hack can be spread to the other devices laterally. So this is known as lateral movement, when the compromise spreads from one system to another laterally inside the network. Next is the external scan. So external scan is run from the outside of the perimeter, or you can say the internet. It identifies vulnerabilities in public facing assets like web servers, VPNs, DNS servers. So of course, if some of your devices are not accessible from outside, they will not be accessible to the scanner as well. So the external scan is mostly for those devices that are accessible from the outside. For example, the web server, VPN, and DNS. And the focus of this is the perimeter security, that how secure your perimeter, your network perimeter is. Next is the agent versus agentless scanning. So agent-based scanning is where the software of the scanners or the agents of the scanner is installed on each host. So it gives us continuous monitoring, and it is great for offline or remote laptops. So in the agent-based or agents scanning, the agent is installed on each and every host, and so this agent can scan the host offline. Without the external connectivity, the scanning can take place, it can be scheduled, and it will take place even without this host connectivity to the outside or internal network. And next is the agentless. So agentless is the remote scanning over the network. So in this case, we do not have any agent over the host, and the scanning is done from the outside, either through APIs or through SSH or WMI, and this has lower overhead on host. Of course, there is no agent installed on host, so there is no lower overhead over the host, but requires network access and credentials. But for this agentless scanning, you must have the connectivity to the host, as well as for credential scanning, you must have the credential of the host as well. Next topic in scanning is the scan depth. So in scan depth, we have two types of scanning. One is credentialed scan. So this is the scanning where we have the administrative rights of the host or the application that we are scanning. So this type of scanning reveals missing patches, registry issues, and software version inside the OS. So this is, you can say, the deep scan, where we have access to the internal application and host, and where we can scan each and every issues inside the operating system, inside the application as well. On the opposite side, we have the not credential scanning, where scanning is done from the outside. We do not have the credential of the host, and in this case, the scanner only sees the open ports and maybe service banners. So this is how the hackers, or this is what the hacker sees from the outside world. So you can say this is the real world scenario from the outside world. But then the credential scan, as we studied, is necessary for to thwart the, you can say, the insider threat as well, because the insider has the access to these system, they have the credential. So if the scanner can identify the vulnerabilities and the weaknesses, these can also be exploited by the insider, malicious insider as well. Next is the passive versus active scan. So passive scan is scanning the network traffic to identify assets and vulnerabilities without sending packets to the target, and this has a zero risk of crashing system. So in this case, we just capture the network traffic and we look for the different targets, hosts, look for packets they are sending and receiving, and look for different vulnerabilities. So we are not actively scanning traffic to the host. So then if we are not directly interacting with the host, there are no chances of crashing the application or the host. On the other hand, the active scanning is directly interacting with the target. So we probe for specific responses from the host or from the target, and this one is more accurate and deep, but also carries a risk of knocking over the services or crashing the services. Discovery and fingerprinting. So mapping is determining the network topology and active IP addresses, and this is most commonly done through network mappers such as Nmap and other IP scanner, or you can say network scanner. Fingerprinting is analyzing the TCP/IP SAC responses to identifying the operating system version, and the hardware type. So it is essential for profiling the shadow IT. So shadow IT are the IT devices or the applications that are used by the organization or by the employees without any approval. And legacy devices, so there may be some legacy devices, so using the version, operating system and hardware type, we can identify these devices. So next topic is security baseline scanning. So baseline scanning compares system configuration against a defined secure standard. So for example, we have a specific set of configuration that we say that this is our baseline, and all other systems must be according to this baseline. Their security configuration must be at par with these baseline configurations. So keeping in view and in mind these baseline configuration, we can scan other systems to see that whether these systems have this baseline configuration. So it identifies configuration weaknesses rather than software vulnerabilities. So here we are talking about specific set of security configuration. You can say we are identifying the misconfiguration rather than software vulnerabilities. So the answer is this type of scanning answers that is this system configured securely and according to the best practice, or according to certain benchmarks such as CIS benchmark or some other security configurations. So security baseline, for example, PCI DSS, we may have some baseline for PCI DSS. So payment card industry data security standard, it is mandatory for any organization that stores, processes or transmit payment card data, and it is mandated by the Payment Card Industry Security Standards Council. So PCI DSS vulnerability scanning requirements are quarterly internal scans. So as we studied in the earlier slides that the scanning may also be done due to compliance requirement. So PCI DSS requires that the internal scan should be done quarterly. So scan all in-scope system internally every 90 days. Quarterly external scan, so must be performed, the external scan must be performed by an approved scanning vendor, that is ASV. Then we have the post-change scanning, that is to rescan after any significant network change. As we said in the previous slides that if we patch the system or if we have new system inside the network or there are some network configuration changes or topology changes, we may rescan the system, which is known as post-change scanning. And then we have the penetration testing, which is annually internal and as well as external. So what's the difference between penetration testing and the vulnerability scanning? So So in vulnerability scanning, we only identify the vulnerability and weaknesses inside the system, while the penetration testing goes one step further. It also identifies the vulnerabilities and weaknesses, but also tries to exploit them. Next is the security baseline of CIS benchmarks. So CIS is the Center for Internet Security Benchmarks that provide consensus-based secure configuration guidelines. So these guidelines or these benchmarks are free to download at cissecurity.org, and they are available for virtual every major operating system, application, and cloud platform. So how to do the baseline scanning against the CIS benchmark? So tools like Nessus, Qualys, and Syscat Pro scan systems against these CIS benchmarks. So these scanners or these tools have built-in CIS benchmarks, and then you can scan systems against the CIS benchmark. So it generates the pass or fail report for each benchmark item. It prioritizes level 1 findings for immediate remediation. So level 1 are the critical findings, and it prioritizes them for immediate remediation, and use results to harden system images and deployment templates. So next is the ISO 27000 series baseline. So ISO is the International Organization for Standardization Information Security Standard family, and it provides framework for establishing, implementing, and maintaining an information security management system, that is ISMS. So ISO 27001 baseline scanning relevance. So organizations seeking ISO 27001 certification must demonstrate vulnerability management controls. Scanning results serve as evidence during certification audit. So these vulnerability management controls are requirement, and the scanning results should be shown during audit or during certification audit. So if the organization have performed these scans, they have the result. It means they can produce them during certification, and they have the chance of passing the certification audit. On the other hand, if they don't have the result of these scans and they haven't performed these scans, then it will be difficult for them to gain this ISO 27001 certification during certification audit. So remediation tracking demonstrates continuous improvement. So objective 2.2, given a scenario, analyze output from vulnerability assessment tools. So now we talk about different vulnerability assessment tools. So the cybersecurity analyst, cybersecurity certified analyst, or CySA Plus, requires interpreting tools output, not just memorizing the definitions. So each tool category serves a distinct phase. For example, some tools are used in the discovery phase, then some in the exploitation validation, some in web application testing, infrastructure scanning, cloud posture, and breach simulation. So each of these phases has separate category of tools, and you must know these tools as well as their output. First of all, we begin with the network scanning and mapping, and this is how the discovery or scanning begins. So first you must know that which are the hosts, what are their IP addresses, which ports are open, and so on and so forth. So the first one is the Angry IP scanner. So this one is Angry IP scanner is a lightweight GUI based cross-platform IP and port scanner, and it outputs gives live host names, MAC addresses, open ports, and response time. So for example, if we look at this screenshot, so this is from Angry IP scanner. You can give a single IP address or an IP range. You can give the you can say the subnet mask, and then you can you can also give the host name where these hosts or these IP addresses will reside, and then you can click the start button and the scan will start. This icon basically shows the processing of the scanning, and this highlights that whether the scanning is in progress or it has stopped. So here we can see that this host, the red one shows that this IP address is offline, the green shows that this is online, as well as the latency or response of the host as well, and then the host name if available, the ports that are open on this specific host, and the web application or web server that are available on these hosts. So this is a type of, you can say, output, very easy to understand even for beginners. And the use case is you can use this tool for quick discovery and sweep on small to medium networks. So for example, if you have a network that have, let's suppose, 100, 200 IPs, you can use this tool very easily for quick discovery. Next one is the mass scan. So again, this one is extremely fast, and it is asynchronous port scanner, and it can scan the entire IPv4 internet in minutes. I don't know, and I am not sure about this statement, but again, this one is very fast. And the output of this is again discovered open ports, such as, let's suppose, port 443 TCP on IP address 192.168.1.50, such as here we can see. So this tool, you can say that this is also available inside Linux operating system such as Kali. If you don't know Kali, you must search. Kali is basically largely used, is a security focused operating system that has all the built-in tools for penetration testing, for scanning, as well as for exploitation. So this mass scan is also available inside Kali, and it has this simple command. You write mass scan, then the network address. So here we are scanning the complete network of 172.217.00/16. Then we can scan for specific port. So here we are -P means for port, and we have given comma separated ports of 80 and 440. So we are specifically scanning for HTTP and HTTPS, or you can say web ports. And then you can also set the scanning rate. So as we studied in the earlier slides, if the system is fragile and legacy, or if the system is critical, such as ICS or OT, we will reduce this rate, and this is the type of output that it gives. So it is showing that we have discovered port 80 on these hosts, 25.207, 2400, then port 443 on this. So you must understand that how this work. It is again very simple. It shows the IP address and the ports, open ports on that IP address, and the port are those that have you specified in the command. So use case is, it is used for large scale internet facing asset discovery, often run before Nmap. So the Angry IP scanner is for a small and medium network, while the mass scan is fast and efficient, and it can be used for a large scale internet facing networks or assets. So next tool is the multi-purpose tool, that is Nmap or network mapper. So it is used for host discovering, port scanning, service detection, and operating system fingerprinting. And it also shows the port states. So for example, the port may be open. Open means that the host is actively listening on these ports. They may be closed, which means the ports are reachable, but there are no service running on these ports. Or filtered, which means that these ports are available on the host but are blocked by the intermediate firewall. Use case is to identify outdated services, validate the firewall rules, and confirm asset inventory. So how you will validate the firewall rules? So for example, in firewall you have you can say denied the access to port 443, then it will show here the port as filtered. So if the scanner is showing the port as filtered, it means that your firewall rule is working. And you can also, again, just like the Angry IP scanner, you can scan a network using this Nmap, and it will shows all the alive IP addresses, so you can confirm your asset inventory. So next one is the Metasploit framework, also known as MSF. So as I said in the previous slides, 2 slides ago, that Kali Linux, a very popular operating system, has most of these tools. So this MSF or Metasploit framework is also available inside Kali Linux. So this one validates whether a vulnerability is actually exploitable. So you can say this is a pen testing tool which actually exploits the vulnerabilities. Key components of this tool include the exploits. So these exploits are basically the attack codes. Payloads are basically the post-exploitation action, that what you want to perform. For example, you want to create a backdoor, you want to get the CLI of that host, so this is the payload. And then the Meterpreter, which is the interactive shell that this tool provides to that specific host, where you can send commands, CLI commands to this Meterpreter. Use case is to confirm the scanner findings. So in the first page, let's suppose we use the scanner, let's suppose a vulnerability scanner, where it shows a specific host as a specific vulnerabilities, and then we can use Metasploit to confirm whether those vulnerabilities are in fact available and exploitable. So it confirms the scanner findings are real, and thus reduces the false positive, and also to test the detection capability. So next multipurpose tools are Maltego and Recon-NG. So Maltego is a visual link analysis and open source intelligence tools. So this tool graphs the relationships between domain names, IP addresses, emails, and people. So it provide a visual link or a visual you can say mapping between domain, IP addresses, email, and people. Very interesting. And the use case is to map attacker infrastructure, trace the phishing campaign origins. Next is the Recon-NG, and this tool has a modular CLI open source intelligence framework which has a Metasploit style workflow. Output is in the form of tables of discovered host, subdomains, and contacts. And use case of this tool is to automate external attack surface discovery. So now coming over to some web application scanners, and the popular ones are the Burp Suite and Zap. So Burp Suite is industry standard web application testing platform, and it has a proxy, scanner, repeater, and intruder. Output is, it shows the issue, which may be, let's suppose, for example, SQL injection. It shows the severity of that issue. For example, severity may be high, medium, or low, and the confidence of that discovery. So confidence may be low, high, or certain. So use case of this suite is to identify OWASP top 10 web issues and manually validate these findings. Next, next tool is the Zap, that is Z Attack Proxy. So again, this is a free open source OWASP scanner, and it is main alternative to Burp Suite. This suite supports CI/CD integration for DevSecOps. So CI/CD is used in software development life cycle and it is continuous integration, continuous delivery. So we can integrate this suite in this pipeline for DevSecOps so that we have the development and the security integration in the form of this tool in this CI/CD pipeline. So use case is to do the free automated scanning and pipeline integrated baseline scans. Next web application scanner is Nikto. So it is a CLI scanner focused on server misconfiguration and known vulnerable files. And a sample output of this tool is, let's suppose it gives you the here we are it is giving us that the admin login page found. Backup.sql is potentially sensitive file that has been found by this tool, and it is also showing us that the Apache has an outdated version which has multiple CVEs. For example, the Apache version that this tool found, there are multiple CVEs with this outdated version. So use case is for quick misconfiguration check, lightweight initial reconnaissance. Next is a very popular vulnerability scanner, Nessus. So it is most widely deployed commercial scanner and it has 80,000 plugins. Sample output is name. For example, it gives you the name of the vulnerability, SSL certificate cannot be trusted. Then it gives the scoring of that vulnerability. For example, score is 6.5. It means the vulnerability is of medium severity, and if the score was toward 10, for example, it was 8 or 9, it means it may have the severity of high or score of critical or high. So CVSS severity scale is from 9 to 10, it is critical. From 7 to 8.9, the severity is high, and from 4 to 6.9 it is medium, and from 0.1 to 3.9 the severity is low. So use case is comprehensive credential scanning, compliance scanning such as we studied for PCI DSS and SIS benchmark. So this tool requires credential of the target web application, so it gives us comprehensive credentialed scanning. So you need to have all the topics and understanding in mind. So for example, if you don't know credential scanning, you will be confused over here that what are we talking about. So we study about the credential scanning where we require the credential, for example, the username and password of the target application or host to do that scanning. Non-credential scanning that is performed from the outside, such as the one from the hacker point of view where the malicious actor has no access or no credential of the target system. Next is the Nuclei and OpenVAS. So Nuclei is a fast YAML template-based scanner with community-driven template library, and output is in the form of CVE, and this is the date when the CVEs were discovered. This is the specific number for that CVE. This gives the severity of that CVE. In this case, it is critical, and this is the name of that specific CVE, and this shows that this specific CVE or vulnerability is detected. Use case is for rapid scanning of newly disclosed CVEs and CI/CD pipeline integration. Next is OpenVAS. So it is free open source alternative to Nessus, and it has the Greenbone framework. Output is in the form of NVT findings with again CVSS severity, the port number, and the summary. Use case is for budget conscious comprehensive internal scanning. So next is the cloud infrastructure assessment. So for example, if we have a private cloud, how do we assess its vulnerability? I think for the public cloud, you need to have that permission to do scanning on this public cloud. So first one is the Scout suite. So it is an open source multi-cloud auditor. For example, it is applicable on AWS, Azure, and GCP. And its output is in the form of HTML report flagging misconfiguration by service, for example, identity and access management, storage, and networking. And use case is quick multi-cloud posture assessment. Next is the Prowler. So it is AWS focused, multi-cloud capable, and it maps to CIS CIS AWS benchmark. Output is in the form of it shows fail or pass. Ensure S3 bucket have public access blocked. So it means the CIS benchmark here is failed. It is not as per the configuration is not as per the CIS AWS benchmark. So your cloud configuration has failed this benchmark, which means that you need to ensure that S3 buckets public access is blocked. Currently, it means that currently the public access is open. Use case is again CI/CD integration compliance checks and pre-audit prep for SOC 2 or PCI DSS. Next cloud infrastructure assessment tool is Trivy. So it scans container images, infrastructure as code, dependency, and generates SBOM. So output is again in the form of CVE, where this is the year of the CVE and when this CVE was discovered, this is the particular number of unique number of that CVE, and this is the severity which is high, and the CVE is open SSL, inside open SSL, and this one again give the number. I think this gives the version number that this CVE is applicable to, or the open SSL version that is for which this CVE is applicable. So the use case is that it scans container images before deployment, and it provides shift left security. Shift left security means if we have a timeline, shift left means to integrate security from the beginning, such as in the design phase or in the requirement gathering phase if you are talking about software development, or the system configuration or system design. Next is Checkov. So it is static analysis tool for infrastructure as a cloud platform, such as infrastructure as a code platform such as Terraform, CloudFormation, Kubernetes, and it gives static analysis for ASE before deployment. Output is again in the form of CKV-AWS-20, and the specific vulnerability is that S3 storage bucket allows public read, and your benchmark is again failed. Use case is that deployment gate in CI/CD, it prevents misconfigured infrastructure from shipping. So our next topic is breach attack simulation, that is BAS tools. So BAS or breach attack simulation tools test whether defenses actually detect and respond to attacker behavior. So it is different from vulnerability scanning, which only finds weaknesses, but this one answers if a real attacker did this, would we catch it? For example, if real attacker was scanning our network, would we be able to detect that scanning and prevent it or block it? So we have two types of these, you can say, BAS tools. First one is Atomic Red Team versus Caldera. So Atomic Red Team is an open source library of small tests that are mapped to individual MITRE attack techniques. It is lightweight and tests one technique in isolation. Example is T1003.001 LSAS memory dump via proc dump. Use case is to validate specific detection rules and purple team exercises. Next is Caldera, which is a MITRE's automated adversary emulation platform, and it is full multi-stage, provides full multi-stage attack chains. It is agent-based with pre-built adversary profiles mimicking real threat actors, and use case is full APT style emulation, continuous detection and coverage, continuous detection coverage validation. So this is a comparison of atomic red team versus Caldera. So the aspect is scope. So atomic red team is a single technique, while Caldera provides full attack chain automation. So the atomic red team is manual per test, while Caldera is fully automated. And use case is atomic red team is for targeted validation, while Caldera can be used for comprehensive emulation. Objective 2.3, given a scenario, analyze data to prioritize and mitigate vulnerabilities. So we are going sequentially. First we scanned the vulnerabilities, then we interpreted the output of the scanners, and now after we have the vulnerabilities, we need to prioritize them, and after prioritization we will mitigate them. So let's get started. So what is vulnerability prioritization? So not all vulnerabilities are equally urgent. Scanners can produce thousands of findings, and analysts must prioritize based on real world risk to the organization, not just severity score alone. For example, a vulnerability may have a very high severity score, but we need to be cognizant of the fact that we need to keep in mind our own organization, that whether this severity is applicable to our own organization. So the severity score alone is not the, you can say, criteria for prioritization of the vulnerability. So prioritization combines exploitability, asset value, threat intelligence, and business context. So business context of each organization may be different for each vulnerability. So what is the prioritization criteria then? So the criteria includes multiple factors. First one is the exploitability. So it measures how easily a vulnerability can actually be exploited. If it is easily exploited by even unnovice hackers or by, you can say, unexperienced hackers, then it means that its prioritization must be high. And if it is very difficult to exploit, then we may list down the prioritization of that specific vulnerability. So a critical CVSS score with no practical exploit path may be lower priority than a medium score with a working public exploit. Next criteria is active exploitation and threat intelligence. This means that prioritize vulnerabilities currently being exploited in the wild or theoretical ones. So if the vulnerability that is discovered is actually being exploited in the real world and its exploit is available, then it means it requires urgent attention. And threat intelligence reveals which CVEs attackers are actively weaponizing. So using the threat intelligence, we can determine that whether the CVEs discovered are being actually exploited in real world or not. Next criteria is the, of course, the asset value. When we talk about the context of the business, so this is what we are talking about. So the asset value for each organization may be different. So for example, for one organization, the vulnerability may be discovered in a public information sharing site, which may be of low value to the organization, and the same vulnerability may be discovered for other organization in a critical database having critical data. So for each organization, the vulnerability that is discovered inside a specific asset, its asset value determines the actual prioritization. So the business value of the affected system drives the prioritization. Same vulnerability on a domain controller versus a test server carries very different risk. Next is the impact, of course. So potential consequence if vulnerability is successfully exploited. and this consider confidentiality, integrity, and availability, that is CIA impact. So, for example, if we are talking about the credit card data, then the confidentiality of that data is very high and also impact is high. So the next criteria is patch and remediation availability. So whether a fix actually exists changes the response strategy entirely. So if the fix is available, the response would be to immediately apply it. If it is not available, then we may need to apply some alternate compensating controls to cater for this unavailability of the fix or patch. Next is the true and false positives and negative. So accurate classification of scanner findings is essential before prioritization. What does this mean? This means that sometimes the scanner may show that there is a severe vulnerability that is available inside the application, while in fact the vulnerability will not be available and the scanner may be showing false positive. False positive means that the scanner shows that there is a weakness or vulnerability while in fact there is none. So we may need to validate, or we must validate the finding before assigning resources for remediation, and we need to investigate why false negative occurs, scanner coverage gaps, and credential issues. False negative means that there is issues or vulnerabilities inside the application, but the scanner did not find it. So this issue may be due to scanner is not able to scan all the area or all the, as we talked about in the earlier slide, or the network segmentation and VLANs areas, and sometimes the credential put inside the scanner may not be correct. Next is the vulnerability scoring methods, and the first one is the CVSS, which is Common Vulnerability Scoring System. So this is an industry standard severity scoring framework, and it produces a score from 0 to 10 based on technical characteristics. And the CVSS metric groups include the base metrics, which are intrinsic vulnerability characteristics such as attack vector, complexity of the attack, privilege required for the exploitation, and impact of the attack. Then next is the temporal metrics, which are the factors that change over time. For example, the exploit maturity. Initially, the exploit may not be mature, but with passing time, the exploit matures. And then remediation availability. So remediation may not be immediately available, but with the time the remediation also become publicly available. Next is the environmental factors, which are organization specific context. So this may be different for each organization, which is modified impact based on your environment. So for each environment, the impact may be different as per the context of the organization. So next is the EPSS, which is Exploit Prediction Scoring System. This predicts probability a vulnerability will be exploited in the next 30 days. It is maintained by FAST, which is the Forum of Incident Response and Security Teams, and it produces a probability score from 0 to 1, that is 0% to 100%. So why the EPSS matters? So CVSS tells you how bad the vulnerability could be. EPSS tells you how likely it is to actually happen. So CVSS tells about the vulnerability itself, that how bad or worse it is, while EPSS tells us that how likely it is to actually happen. So combining CVSS plus EPSS gives far more accurate prioritization than CVSS alone. For example, the CVSS 9.8 score, which is critical, plus EPSS 0.02, that is 2% likelihood, is a lower urgency than expected because the occurrence of that particular vulnerability or exploitation of that particular vulnerability inside the organization is very low, so we may have low urgency. On the other hand, a CVSS score of medium, that is 6.5, with EPSS of 94% likelihood, which is very high likelihood, requires urgent remediation priority. Next is the context awareness. So we may have different contexts. First is the internal context, which is vulnerability exists on the internal only system, not directly internet accessible. So here we may have the insider threat and not the outsider threat, because the system is not directly accessible from the internet. So it requires attacker to already have network access, and it reduces the immediate urgency because the attacker is not able to access that application or that network. But still it is critical for lateral movement prevention. Lateral movement prevention from the insider threat mainly, because since if the attacker is not able to access even one system from the outside, he or she is also not able to do the lateral movement, but this all mainly is applicable to malicious insider attacker. External context is that the vulnerability exists on internet facing system that is directly reachable by any attacker. So this has the highest priority, no prior access is required, largest attack surface. So we have the largest attack surface because it is accessible from the whole world, that is internet. For example, the web servers, VPN gateways, email server and exposed APIs all has the largest attack surface and highest priority. Next is the isolated context, that is where system is segmented or air-gapped with no network path from untrusted zone, whether external or internal. This significantly reduces the practical exploitability despite vulnerability existence, and it is common in OT and industrial control system environments with strict segmentation. Risk acceptance is more justifiable when isolation is verified and maintained. So next, after prioritization, the next stage is the mitigation strategy. So mitigation strategy is to do the attack surface management. So attack surface management or reduction basically reduces the number of exposed entry points that are available to attackers. It is a proactive strategy that which shrink what needs to be defended. So if you have less exposed application or services, it means there are less to defend. Key actions are to decommission unused systems, services and account, very important, and close unnecessary open ports and disable unused services. So these steps are also known as system hardening that we studied in our previous domain in previous slides. Reduce the internet facing footprint where possible, and continuous asset discovery to find the shadow IT and forgotten system, and regularly review and remove the excessive access permissions. Next is the secure coding best practices. So this prevents the vulnerabilities from being introduced during development, and the shift left approach, which fix issues before they reach production. What does shift left mean? So if this is the timeline, so time increases in this direction, in the right direction. For example, if this is day 1, this is day 2, this is day 3. So shift left means to fix the issue in the very initial phases, for example, before the development actually starts or before the production, in the design phase, in the information gathering phase. So this, when you do the shift left approach, you can fix the issue before they reach production, and it is easy to fix the issue in the initial stages. Key actions include the input validation and output encoding, which prevent injection attacks, parameterized queries which prevent the SQL injection, secure authentication and session management, code review and static analysis, that is SAST, integrated into CI/CD, and dependency scanning for vulnerable third-party libraries. So next, is the patching and configuration management. So it is the most common and direct remediation method, that is patching and the configuration. Patch management consideration include to test patches in staging before production deployment to prioritize based on combined CVSS plus EPSS plus the asset value scoring. Emergency patching process for actively exploited critical vulnerabilities, and to track the patch compliance, that is percentage of systems patched within SLA. So this can be done through KPIs or KRIs. Configuration management is to enforce secure baseline configuration, for example using the CIS benchmarks, use configuration management tool to prevent the configuration drift, and regularly audit configuration against approved baseline. Exceptions include formal risk acceptance when remediation is not immediately possible, but this risk acceptance must be documented, approved, and time bound, never indefinite. So what are the compensating controls? So these are alternative security controls that are implemented when direct remediation is not feasible, and they reduces risk without fixing the underlying vulnerability directly. And when compensating control are used, so these are used for legacy end-of-life systems with no available patch. For example, if you are still using Windows XP or even Windows 10, which Microsoft has made UL, you need to have compensating control for those systems that has no patch available no longer. So vendor has not yet released to fix. For example, some system may not be OL, but the vendor may not have released a fix for a certain vulnerabilities. Patch would break critical business functionality, very common in OT and ICS. So if a patch is likely to break the business functionality, we may need alternate compensating control instead of patching the system. And the system scheduled for decommission soon. So if you are going to decommission a system then and patching is not cost effective, we may need compensating controls. So validation of remediation is important, that validation confirms that remediation actions were actually effective. That is, we never assume success, but we always validate it. Critical final step often skipped, but may lead to false sense of security. And validation methods include to again rescan the same tools. So run vulnerability scan again to confirm that the scan now finds no vulnerability that were previously found by the scanner. Manual verification is to confirm patch version installed on the system and configuration applied correctly. Penetration testing is to attempt exploitation again to confirm it no longer works, and continuous monitoring is to ensure compensating controls remain active and effective over time. So validation best practices include to never close a remediation ticket without confirmed validation, to document the validation evidence for compliance and audit purposes, and to revalidate the compensating controls periodically, and configurations can drift. So track remediation validation rate as a SOC efficiency metric, Security Operation Center efficiency metric. Our last objective in domain 2, objective 2.4, explain concepts related to control types, risks, and vulnerability management. So let's get started. So our first topic is control types, and we have three main categories of control, that is administrative, technical, and physical. So what are these? What are their example? What does they mean? So the first one is the administrative controls, and these are basically policies, procedures, and training, etc. inside the organization. So they mainly deals with the non-technical things such as security policy, different procedure to do certain tasks, and security awareness training, skill trainings, etc. Example include the security awareness training, acceptable use policy training, and background checks of the employees. Next is the technical, which is obviously the hardware and software mechanisms, and examples include your firewalls, your servers, encryption mechanism, multi-factor authentication, intrusion detection and prevention system. And last one is the physical, which are tangible protective measures. So these are mainly for the physical security of your infrastructure, such as your data center, your office area, your server room. And the physical controls include the locks maybe of the doors, of the server room, of the server racks, badges for the guests, badges for the employees, security guards, CCTV cameras, and fences around your facility. So next, control types are by function. So control types by function include preventative, detective, responsive, and corrective. So these are the types by function, their purpose and example, and the first one is preventative. So this control function is to stop incident before it occurs. So you can say this is a proactive preventative control. An example of this include firewall, MFA, and security awareness training. So we apply different rules on the firewall and prevent certain type of traffic before they reach the organization. Similarly, we do the authentication of accessing the system through multi-factor authentication, and we conduct the security awareness training of the employees to prevent intentional or unintentional exposure of organizational data. Next is the detective. So detective control function is to identify incident as it happens, or you can say it identifies incident when it happens or when it has happened. And its examples include the log alerts such as SIEM alerts, intrusion detection system, which detects the incidents or attacks, and log monitoring. Next one is the responsive. So these control types react to the detected incident. So we are going sequentially. First we try to prevent the incident from happening, and then even when our preventative control fails, we try to detect it as it happens, and once we detect it, we respond to it. So the responsive is a reaction to the detected incidents. And example of this type of control function include incident response plan, our source playbook, and isolation of the infected incident or infected network. And last one is the corrective. So when incident happens, we want to restore our affected incident after the affected systems after the incident. So mechanisms for the corrective function include the backup of the data, backup of the system, the configuration, patching of the systems to patch the vulnerabilities that were able for these, that were responsible for these incidents or the attack, and the affected system restorations. So next is the risk concepts. So we have different types of risk appetite, residual risk, and inherent risk. So we will study these one by one. So inherent risk is the risk level before any control are applied. So this is the risk inside the system organization before we conduct any risk assessment and apply any control. So this is the total, you can say, risk. Residual risk is when we identify risk and we apply certain control to mitigate that risk. But even after applying control, there are some risks still remaining. We cannot reduce the risk to zero. So residual risk is the risk remaining after controls are applied. And risk appetite is the amount of risk an organization is willing to accept to achieve its objectives. So when an organization is achieving its objectives, this is the amount of risk that the organization, you can say the risk variation that organization is willing to accept. So next is the risk management strategy, or you can also say this is the risk mitigation or risk remediation strategies, and these include, once you identify risk, you do the risk assessment, risk management, then you remediate or mitigate the risk, and this can be done through risk acceptance, risk transfer, risk avoidance, and risk mitigation. So these are the strategies, their description and example. So risk accept means to acknowledge the risk and take no action. So when do we accept the risk? What are the scenarios? So these are for low impact probability on isolated test systems. So when the impact of the risk is low or the systems are isolated, we may take no action. Or another way to say this is, when there is a risk, we apply control to mitigate the risk. But if the cost of control is greater than the impact of risk itself, for example, if the damage due to risk is $5,000 but the cost of the control is $10,000, then we accept the risk because it is cost prohibitive. Next is the risk transfer, which is to shift risk to the third party. How do we do that? So it is done through cyber insurance outsourcing to managed provider. So when you outsource your services to MSPs or to managed security provider or service provider and shift the risk over there, or when you buy the cyber insurance, this is a type of risk transfer strategy. Next is the risk avoidance, which is to eliminate the risk causing activity entirely. So in this case, we decommission the vulnerable legacy system. So it is not just for the legacy. For example, if we have a legacy system and there is no patch or no updates available for that system, so what we can do, we can avoid the risk by decommissioning the system altogether. Another example is, for example, if we are performing an activity, for example, if the organization is planning to, let's suppose, digitize its HR system, but there are real threats to that digitization from the internet facing or from the hackers, the organization may avoid this digitization and eliminate the risk causing activity altogether. So this is not applicable to only legacy system. This is applicable to any activity that organization may seem very risky, and they may eliminate or stop the activity altogether. Next is the risk mitigation. So in this activity, this is the activity or the mitigation strategy where we actually apply the controls. So this is to reduce the risk likelihood or impact. So we apply the patch, we add the compensating controls to reduce the risk. So we always reduce the risk. We cannot eliminate it completely, or we cannot reduce it to zero. Our next topic is the policies, governance, and service level objectives, that is SLOs. The policies are formal documented rules defining the expected security behavior and requirements. And the governance is the framework of oversight, ensuring that the security policies are followed and enforced. And SLOs, service level objectives, are measurable targets defining expected performance for security processes. So some common security SLOs example include critical vulnerability patched within 7 days, high severity incidents acknowledged within 15 minutes, and 99% of systems reporting to SIEM. So these are different SLO where we can quantify our objectives. And vulnerability scan completed monthly across all assets. Next is some application security testing, and first one is SAST. So SAST is static application security testing that basically analyzes the source code of the application without executing the application. So this is known as white box testing because we need or we have access to the source code internal. So this type of test is usually done before the development of the, or before the, you can say, production and development of the application itself, because we need the source code, and this test is more effective as more cost effective because we do it during initial stages of the application development. Key characteristics of SAST include that it is performed early in software development life cycle before code is compiled or deployed, and this test identifies SQL injection patterns, hard-coded credentials, and insecure coding practices. So this is integrated into CI/CD pipelines. So CI/CD is continuous integration, continuous delivery, which is again the concept of software development life cycle, as automated code scanning gate. So we have automated source code scanning mechanism for this type of test in CI/CD pipeline. Next is the application security through DAST. So it is dynamic application security testing, and it tests a running application from the outside. It is also, so we are now testing the application when the application has been developed and compiled. So we are testing it from the outside, not the source code itself. So this is why this is known as black box testing, because we do not have access to the source code and we only simulate the real attack behavior. Key characteristics of DAST include that it is performed against the deployed or running application, and it identifies runtime vulnerabilities, authentication flaws, and configuration issues. And it finds issues that SAST cannot. So SAST cannot identify issues in a running or deployed application because it is done against the source code. So it identifies the server misconfiguration and runtime logic flaws. So now a little comparison between SAST and DAST. So these are the different aspects for the comparison. So access in SAST, we have access to the source code, while in DAST we do not have access to the source code, but we have access to the running application. So timing of SAST is, it is done early in the SDLC when we have the source code available, while DAST is usually performed after the deployment. You can also do the DAST during staging environment before deploying the application in the production environment. Perspective is that SAST is white box testing where we have access to the source code itself. DAST is black box. It is known as black box because we do not have access to the source code. And SAST finds the code level flaws, while DAST finds the runtime or configuration flaws. So what our next topic is the application security, and it is about SAMM, that is Software Assurance Maturity Model. So Software Assurance Maturity Model is a framework for building application security into SDLC. It is maintained by OWASP, and it helps organizations assess and improve software security practices. So SAM or you can say SAMM business functions include unusual data volumes, that is large uploads and downloads. So it can help us identify these functions. Traffic to non-malicious IP addresses or domains, that is command and communication servers. Abnormal protocol such as HTTP on port 53 and DNS tunneling. Beaconing behavior, that is periodic small connections and lateral movement between segments. So our next topic is third-party risk, that is supply chain risk. So these are the risks introduced through vendors, suppliers, and partner with access to our system or data. So supply chain risk is introduced through vendor, suppliers, and partner. And modern attacks increasingly target the supply chain rather than the target party itself. So supply chain risk example include compromised software update mechanism, for example SolarWinds. So there was a popular SolarWinds supply chain attack where the attackers compromised the SolarWinds company itself, and when these software updates were rolled out to the clients or to the customer and companies, all of these companies that received the updates were compromised. This was a popular supply chain attack, and this is one example of the supply chain risk. Next is the third party, another example is third party vendor with excessive network access. So if an organization has given excessive network access to a third party, they may be exposed to risk, supply chain risk due to that third party. So if that third party is compromised or that vendor is compromised, the company itself may be at risk. Next is the open source library containing malicious code. So if we use the open source library in our application development, if we use malicious libraries, then these libraries will also affect our application as well. Hardware tampering during manufacturing or copying. So another supply chain risk example is hardware tampering during manufacturing or shipping. So a popular supply chain risk example of hardware tampering now comes to my mind in recent days when Israel Mossad tampered, or you can say compromised, the pages that were meant for Hezbollah operatives, and they were later exploded and it caused severe damages to many operatives of the Hezbollah. Many were murdered and many were injured. So this is a typical example of supply chain risk through hardware tampering. So what are some mitigation approaches of the third-party risks? So these include vendor security assessment before onboarding the vendor, contractual security requirements to SLAs and right to audit clauses, continuous monitoring of vendor security posture, and to limit the third-party access using least privilege principles. So our next topic is the in third-party risk is software composition analysis, or SCA. So this identifies open source and third-party components that are used within an application, and it detects known vulnerabilities in dependencies. Key capabilities include that it scans application dependencies and libraries, cross-references against vulnerabilities database, that is National Vulnerabilities Database, and it identifies outdated or unmaintained components and flags license compliance issues. So why the software composition analysis matters? So modern applications often contain 70 to 90% open source code, so a single vulnerable dependency can compromise the entire application. And next third-party risk is the software bill of material, that is SBOM. So this is a formal structured inventory listing all the components, libraries and dependencies in a piece of software. It functions like an ingredient list for that software. So why does this matter? So it enables rapid identification of affected systems when new CVEs are disclosed and is increasingly required by regulation, for example, in US Executive Order of 14028 for federal software, and it provides supply chain transparency to customers and auditors and is essential for rapid response to incidents like Log4 Shell. So, for example, if a vulnerability is due to a particular, you can say, ingredient or library, and you have the list of all the libraries or you have the SBOM, you can identify that issue immediately if it is discovered, and you can have a rapid response to that incident. So common SBOM formats include the SPDX and Cyclone DX. An analyst use case for SBOM is that when a new critical CVE is announced, for example, Log4j, the analyst need to search the SBOM across the environment to immediately identify every affected application. Without this, identify expose could take days. So if you have the SBOM and a new vulnerability is discovered, you will immediately go to the SBOM and will search that whether the organization has any application that has the affected ingredient or the affected library or application. So that's all for domain 2. Thank you for watching. Please like, subscribe and share the video, and we will see again each other in domain 3. Everyone, and in today's video we will go through the third domain, that is incident response and management. And our first objective 3.1 is summarize concepts related to attack methodology frameworks. So what is the attack methodology frameworks, or what are the framework, what are they about, what do they tell us? So these frameworks give analysts a structured way to understand, communicate and analyze the attacker behavior. So if you know your enemy, you know how do the enemy or the attacker attacks, what techniques he or she uses, then you can of course defend against his or her methodology. So each of these frameworks offers a different lens, some sequential stages, relational analysis, and a comprehensive techniques library. So we will go through multiple frameworks, and the first one is the cyber kill chain from Lockheed Martin. So this framework is developed by Lockheed Martin, and this models the sequential stages of a cyber attack. So what do we mean by sequential stages? We mean that how does the attacker goes from step 1 to step 2 to step 3 sequentially. And this is a linear sequential model. It means that it goes step by step. For example, the attacker first gathers, let's suppose in farming, we will go through all the stages, but just for the sake of example, the attacker first go through the, let's suppose, OSINT, gathers public information, then scans the target, the reconnaissance phase, then look for the vulnerabilities, then exploit the vulnerabilities, then create some backdoors, exfiltrate data, etc. So these stages or the steps are sequential. And disrupting any stage breaks the attack chain. So for example, if you block the scanning phase while the attacker is actually scanning your network, you can disrupt the whole attack phase because the attacker has no longer access to your network. So now we will go through all these steps. Basically, there are 7 stages, and the first one is, as I said, reconnaissance. So in this stage, the intruder selects the target, researches vulnerability entry points, and gathers open source intelligence, that is OS end. So these are the publicly available information about the target. Stage 2 is the weaponization, and in this stage the attacker couples a payload, that is a malware or exploit, with a deliverable format. For example, the attacker has the exploit or the malware, how to deliver that? So the attacker may use a PDF document or macro enabled document such as Microsoft Word to deliver that malware. So this stage is weaponization. Third phase is the delivery. So we weaponized or you can say we made the, just for the sake of example, we made the attacker made the bomb. Now how to transmit it to the target? So this is the delivery phase. So transmission of the weaponized payload to the target, for example, either through email or the USB or the web exploit. For example, now how to deliver that PDF document to the target? It may be done through some phishing email, through USB device, or through some web exploit. So the next stage is, that is stage number 4, exploitation. So now you can say the exploit has been delivered to the target. Now it is the time to exploit the target. So triggering the malicious code to run, targeting either a system or a user vulnerability. So after exploitation, the stage number 5 is installation. So executing the malware to establish a persistent backdoor or registry run key on the target. After the backdoor, stage number 6 is C2, that is command and control, and in this stage an encryption communication channel is established back to the attacker external command server. So now the target, let's suppose the target was a laptop. That laptop now has an encrypted communication channel to the attacker server. And last and 7th stage is action on the objective. This includes executing the primary target goals. That is, the goal may be either the data exfiltration, encryption of the system files through ransomware, or disruption of the system itself. Our next framework is the diamond model of intrusion analysis. So in this we have these different, you can say, methodologies or these different stages. So in this analysis model we have the adversary, in which we determine that who is the actual attacker of the attack. This may be the actual attacker, the threat group, or the nation state sponsor. So whichever the adversary is, we determine it. Next is the capability, that is how. So it means that which tools were used by the attacker, which exploit script were used, which malware was used, and which techniques were used in the attack. So who was the attacker, how the attacker exploited the system, which were the tools, which were the malware and other techniques. Next is the infrastructure, that is where. So this is the IP addresses, the domain name, C2 network, or email address utilized during the breach. So we are talking, these are the information about the attacker. So which IP addresses were used by the attacker, what was the domain name, what was the command and control network and server, what were the email addresses utilized during the breach by the attacker. The victim, that is the target, so which was the target organization, whether it was an individual user account or a specific infrastructure system such as servers, database systems, or network. Next is the activity thread, that is staking multiple diamonds sequentially to map out a multi-phase evolving campaign over time. So there may be multiple attacks by these same actors or by multiple actors. So activity thread is analyzing all these attacks and mapping them out with each other. Next one is the popular MITRE attack framework. So this is a comprehensive real-world knowledge base of adversary tactics and techniques. So we have already covered this framework in domain 1. So here we will go through a quick recap for incident response context. So in MITRE attack we have the tactics. So these are the threat actors' high-level tactical goals, for example initial access, persistence or privilege escalation. Then we have the techniques. So these are the specific technical actions that threat actors perform to achieve a tactic. For example, the technique used by the attacker may be spear phishing or registry run keys. Then we have the sub-techniques. So these are detailed variation of a specific technique. For example, the spear phishing attachment versus the spear phishing link. So the spear phishing is a technique, but this technique may be used through, let's suppose, email attachment, or by just sending a link through email or other web links for the same spear phishing purpose. Then we have the procedures. So these are actual real-world step-by-step execution details that are observed in real-world campaign. For example, APT29 executing a specific PowerShell string. So a comparison of these three frameworks that we studied. So these are the frameworks and their purpose. So the cyber kill chain is best used for high-level attack stage communication. The diamond model is basically used for linking related incident to same adversary. For example, if you have the if you want to link multiple attacks to the same threat actors or to same adversary, you can use this model. And MITRE attack framework is gives us granular technique level detection and documentation. So our next objective 3.2 is summarize the incident response process. So the incident response process is a structured methodology that ensures consistent, effective handling of security incident. So what we are studying is incident response process. This incident response process that we are studying is based on NIST SP 800-61 incident response life cycle, and each phase in this incident response IR life cycle basically builds on the previous. So skipping a phase in between leads to incomplete response and recurring incident. So we have 7 phases in this IR process. So these are: preparation is the number 1, then we have detection, number 2, analysis, number 3, containment, number 4, eradication, number 5, recovery, number 6, and post-incident, number 7. So this is as per NIST SP 800-61. So in this picture we have listed, I think, 6. So different documentation may list different number of stages and with different names with little variation. So you don't need to worry about them. They are almost identical. You can make sense of this. The important thing is to understand that what happens during each stage. So for example, here we have 7, here we have 6, but you must understand that what happened and during each stage and what's the purpose of each stage. So starting with the first stage, that is preparation. So this is the foundational phase and it occurs before any incident happens. So this stage is not the stage that you will go through during active incident. So you need to prepare yourself for the incident before it occurs. So it determines how effectively the organization will respond when an incident occurs. So in this phase, you develop the incident response plan, that is IRP. So this is a formally during this plan, we formally document the team roles, such as during incident, what will be the roles and responsibilities of different personnels, escalation chains, how we will escalate the issues in the command, and the external communication channels. We also prepare the incident response jump back. So this is basically compiling pre-configured offline forensic tools. So we should have these tools pre-configured, pre-prepared, bootable USB drives, RIOT blockers, and network tabs. So during active incident, you don't have or you won't have time to do all these things. So these things should be prepared before the actual incident. Then we have the defensive hardening. So you need to configure the log forwarding. For example, if you have the SIEM solution, you need to ensure that all your devices are forwarding the logs to SIEM solution. Configuration of the firewalls and the EDR tools, configuration of the endpoint detection and response tools before the incident occurs. Then performing the tabletop exercises to prepare for the actual incident. So running the simulation scenarios with key stakeholders to test the plan effectiveness and response speed. Our next and the second phase during incident response is the detection. So in this phase, we identify a security incident during its occurrence. So this is the stage that we need to identify if a security incident is occurring. So if you don't have a proper detection mechanism, it means that incident may already be in progress or may already have occurred and you will have no clue. So earlier detection significantly reduces the incident impact and cost. And what happens during detection phase? So we have the precursors, which are the signs that an attack may happen in the future. For example, if you see the web port scanning logs, if your logs are showing that there are actual scanning happening of your infrastructure, it means that the attacker may be in the initial phase of the scanning and the actual incident or attack may happen later. High priority threat intelligence alert. So if you have threat intelligence feeds, you may see alerts of such attacks before they occur. Indicators may include hard proof that an exploit is currently underway or has already happened. For example, you may have active reverse shells or abnormal outbound traffic. So if you are seeing this, it means the incident or the attack is already underway. Alerting sources include ingesting, as I said, security logs from SIEM, EDR, firewall, and intrusion detection and prevention system. Our third phase is the analysis, and this is the phase in which we investigate the scope, nature, and severity of the confirmed incident. So now the incident has already occurred. Now we are investigating the scope, the nature, and the impact and severity of that incident. So during analysis we determine that what actually happened, how did it happen, and what systems are affected. So during this stage we have the triad and validation, which means that filtering alert to identify the true positive and weed out the false positive logs. Scope assessment is to determine that which endpoints, servers, network or subnets and user accounts have been compromised by the incident. Impact assessment is calculating the potential damage based on the operational downtime, financial loss or data sensitivity by the incident. And incident prioritization is ranking incident to allocate analyst resources to the most critical threat first. For example, as we said that we are talking about the scope of the assessment, we may have multiple endpoint and servers affected. So prioritization is to prioritize the allocation of resources to the most critical servers or endpoint. Our next stage is the containment. So in this stage, we limit the spread and impact of the incident while the investigation continues. And this stage is critical to prevent further damage without destroying the evidence prematurely. So, for example, if your one system is compromised, we can isolate this system such that the other systems are not affected. So this is containment. So we have the short-term containment, that is taking immediate defensive steps to isolate a threat, for example, disabling the compromised account and changing the VLANs of the affected system. And long-term containment is implementing temporary robust network architecture changes, for example, routing the active attacker traffic to the honeypots. And forensic preservation is performing the live RAM collection and system imaging prior to taking containment actions that modify the volatile data. Our next stage is eradication. During this stage, we remove the root cause of the incident from the environment entirely. So for example, if the root cause was a specific compromised endpoint, we may remove that endpoint, or we may remove the vulnerability inside that specific endpoint. So this goes beyond the containment. We not only isolate the system, we eliminate the threat completely. For example, we patch the system that was the root cause of that incident. So this eradication may include the malware elimination, so locating and permanently deleting the malicious executables, payloads, and scripts. Registry sanitization is reverting the unauthorized registry changes, scheduled tasks, and persistent hooks. Vulnerability remediation is patching the exploited software bug, applying secure configuration, or updating the firewall rules. And account remediation is disabling the unauthorized accounts and forcing the password reset on compromised user accounts. Our next stage is the recovery. So during this stage, we restore the affected systems and services to normal business operations, and we do careful validation before system return to production. Careful validation means that we make sure that the systems are actually patched, they are configured, they are secured and good to go in the production environment. So in this stage, we have the system restoration, which means restoring the operational services using the clean verified backup or rebuilding the operating system host from the gold templates. Environment validation is testing the networks and hosts to verify that normal performance has been restored safely. And aggressive monitoring is deploying the enhanced temporary logging rules to watch recovered host closely for any secondary backdoor. So we need to monitor the affected restored system so that we are sure that the systems are no longer compromised or they are no longer sending outbound traffic to the, let's suppose, C2 servers. Then we have the post-incident. So this is the final phase in which we capture the lesson learned and improve our future response to such incidents. This phase is often overlooked under pressure to move on, but it is critical for program maturity. So during this phase, there are lesson learned meetings, which are standard briefing conducted with key stakeholders within days of the incident resolution. The root cause analysis is documenting exactly how the adversary bypassed existing defenses and where the controls failed. Evidence retention is securely archiving the logs, disk images, and incident files to meet corporate policy and compliance regulation. And IRP updates are modifying the IR response plan and defensive security tools based directly on the lesson learned during the incident. Objective 3.3, given a scenario, implement the incident response techniques. And our first topic is developing the plans, that is incident response plans. So this is the incident response plan is a formal document that defines how the organization detects, responds to, and recovers from security incidents, and it is the foundation of the entire incident response program. So these are the key components of this plan. So we have the purpose, scope, and objective of this document, the incident classification and severity definitions, roles and responsibilities, response procedures per incident type, communication and escalation techniques, evidence handling and change of custody requirements, legal and regulatory notification requirements, and plan review and testing schedule. So these are the key components of the incident response plan. Then we have the communication plan. So what is the communication plan? So communication plan defines who communicates what, to whom, and when during an active incident. So a poor communication during incidents causes confusion, delays, as well as the reputational damage for the organization. So we have the internal communication plan. So in internal communication, we have the escalation path, which means who to notify at each severity level or at each level of the incident. Executive notification threshold, which means when does leadership is informed and when do they get involved. IT and business team coordination, which means the clear ownership of the response action, and secure communication channel. So assume that the primary channel may be compromised or may not be available, for example, due to some natural disaster. So what will be the next, or you can say redundant communication channel, secure communication channel during incident. So we have the external communication in which we have the legal counsel. So before any external disclosure of the incident, we may communicate it to our legal counsel, regulatory bodies. So mandatory breach notification timeline. So some breach notification are mandatory to regulatory body. For example, in GDPR, it must be communicated in 72 hours, while HIPAA has the 60 days breach notification timeline. So to law enforcement agencies such as FBI, CISA, if we have the significant incident, so the incident must be communicated to these law enforcement agencies depending upon the incident type and severity, and communication to the customers and general public. So the communication to customer and public is also carried out, and it comes under the external communication. So next is the commencement of the playbooks, roles, and training. So creating playbooks include standard operating procedure, that is SOPs, that outline step-by-step action for responding to specific threats. For example, if we have the ransomware, SQL injection, or phishing, and defining key roles is to formally assigning responsibilities to security analysts, executive leadership, legal counsel, HR, and PR representatives. So these roles and responsibilities must be assigned before the actual incidents. Next is the tabletop exercises, as we already studied. So these are discussion-based walkthrough of hypothetical breach scenarios to evaluate the effectiveness of the policies and the communication channels that we have established. And then we have the simulation trainings, which are active hands-on technical exercises, for example, red team versus blue team, which are designed to test tools, analysis skills, and technical playbooks in real time. Our next topic is the log management, and log management includes the collection of logs and then the correlation of logs. Log collection is aggregating security logs from different devices such as firewalls, operating systems, directory services, and endpoint agents into a central repository such as SIEM or security incident and event management. SIEM centralization is ingesting diverse log formats to create a unified view of security events across the entire enterprise network infrastructure. So log correlation is basically grouping disparate events from different sources to detect complex multi-stage attack pattern, for example, matching a failed VPN login with a database query. Next is the log augmentation, enrichment, and alerts. So log augmentation and enrichment is adding contextual metadata to raw logs such as geo-IP resolution, active threat intelligence reputation, and asset priority ratings. Alerts and notification is establishing logical thresholds within monitoring system to automatically notify the security team when the high risk event occurs. And reducing the alert fatigue is fine-tuning the correlation rules to minimize the false positive, ensuring that analysts focus strictly on high impact events. Next is the incident triage, timelines, and prioritizations. So triage is the initial vetting of the alerts to verify the malicious activity, filter out the false positive events, and identify the active compromise vectors. Next is the establishment of a timeline, so chronologically mapping out the sequence of the attacker events from initial entry to lateral movement to the final actions. And then determining the severity and impact, so evaluating the host criticality that is compromised, the data sensitivity that is compromised, such as the data may be personally identifiable information or patient health information, and operational downtime to score the event's overall threat level. And then the prioritization, which is dynamically ranking the open cases to allocate the incident response resources to the most critical business threats first. Our next step is the forensic evidence gathering. And important during forensic investigation is the chain of custody, which is meticulously documenting who collected the evidence, who accessed it, handled it, and stored the evidence to maintain its admissibility in the court of law. So if you don't have the chain of custody, your evidence may not be admissible inside the court. Data integrity validation is done through cryptographic hashes such as SHA-256. So, of collected data at the moment of capture to prove files have not been modified. So when you collect the data, you take the hash of that data, and when at the later stage you again take the hash at different stages so that all the hashes are similar. If there is a change in the hash value, it means that the data integrity is no longer intact and the data may have changed during, let's suppose, the chain of custody. Next is the preservation, which is saving the volatile memory or RAM first, followed by the system disks, logs and network packets to prevent the data loss. So to prevent the data loss, first you need to preserve the volatile memory, for example RAM, then you can come to the non-volatile memory such as the hard drive or other storages such as SAN. Legal hold is implementing a formal directive to preserve all electronic records, emails and logs relevant to the active or impending litigation. So the legal hold may be due to criminal investigation, due to some compliance regulation, etc. Next is the containment, that is isolation and escalation. And in containment, we need to isolate the affected targets. So this means taking the rapid action to quarantine the compromised system, such as disabling the active user accounts or moving the affected host to an isolated system so that the compromise does not spread to other hosts. For example, if these are all compromised hosts, we need to change the VLAN of this host so that they may not communicate with other hosts. Microsegmentation is implementing the granular firewall routes to prevent the lateral spread of malware or attackers to the neighboring network zone. So usually, if let's suppose these all are Microsoft hosts where we have the Windows operating system, usually all these hosts communicate with each other. In microsegmentation, we segment the network at the very granular level, for example at VM level or at host level, so that individual hosts or VMs are not able to communicate with each other if not required. So for example, in this case, if one host is compromised, the compromise will not spread laterally to other hosts. Escalation is systematically raising the threat tier and involving senior management, legal departments or third-party incident response teams when the containment of the incident fails. So if the organization is unable to contain the incident, it may be escalated. Then we have the remediation, verification and the release. So what happens during these phases? So during system remediation, we eliminate the vulnerabilities that allowed the initial access, applying the security patches against the vulnerabilities and purging all threat actor artifacts. Remediation verification is executing targeted vulnerability scans and baseline audit scripts to confirm that systems are fully secured. And then we release the system from isolations, which means safely returning the clean, verified host and accounts to the production after securing authorization from the stakeholders. Next is the restoration and recovery. During this stage, we perform the restoration, which means recovering files and applications using clean offline backups or rebuilding systems from secure gold images. And next we have the service validation, which is monitoring the system performance, network latency and application behavior to ensure that they are functioning correctly post recovery. And then we have the aggressive post recovery monitoring, which is implementing the short term enhanced auditing and verbose logging policies on restored system to catch the potential secondary backdoors. Then we have the root cause analysis, that is RCA and corrective actions. So these root cause analysis is investigating how exactly the adversary bypassed our security controls and identifying the structural weaknesses inside the system and the network to prevent such incident from occurring again. Documenting the timeline, so comparing the attack timeline with internal logging thresholds to find gaps in the security visibility. And then the aggressive post-recovery monitoring, which is to implement short-term enhanced auditing and verbose logging policies on the restored system to catch the potential secondary backdoor. So that's all for domain 3. So welcome back everybody to our CompTIA Cybersecurity Analyst course, and today we will go through our last domain, that is domain number 4, and it is reporting and communication. So this is a brief domain, a couple of slides, about 20 to 22 slides, so it won't take much time. And our first objective is objective 4.1, that is explain the importance of vulnerability management, reporting and communication. So this domain is all about reporting and communication. Let's get started. Vulnerability management reporting. So what is the reporting part of vulnerability management? Effective vulnerability management requires more than just the scanning, which is finding must be clearly communicated to the right stakeholder in the right format to drive remediation action. So when you have done with the scanning, you have found out the vulnerabilities. These vulnerabilities then must be clearly communicated in a required format to the desired stakeholder for them to be remediated. So reporting bridges the gap between technical findings and the business decisions. The vulnerability scan reports and compliance findings. So what are vulnerability scan reports? So these are technical documents detailing open ports, missing patches, configuration issues and associated CVSS scores across assets. So these are vulnerability scan report details all the technical requirement or all the technical scanning details that were done, including the open ports inside the system and application, the missing patches, the configuration issues. So these are all the things that are part of the vulnerability scan reports. Then we have the compliance findings. So these are the auditing reports that map raw vulnerability scan result directly to the required regulatory framework. So we have the vulnerability scan reports, then mapping these scan reports to the compliance framework such as PCI DSS, HIPAA and SOC 2. These are in the compliance findings. So this is pure technical, this is related to the, you can say, GRC, C component of GRC, that is compliance findings, and then we have the targeted reporting, which is distributing the detailed technical outputs to the engineering team while presenting the high level compliance checklist to the auditors. Next is the risk scoreboards and action plans. So scoreboards are visual dashboards which track active vulnerability metrics, threat trends, and overall security posture scores across different business units, such as like these. And what are the action plans? So these are structured step-by-step remediation roadmaps outlining which vulnerabilities must be paged first, assigned owners, and target completion dates. So which vulnerability must be paged first? It means we need to have the prioritization. So we need to prioritize the vulnerabilities that which will be paged first, second, and third, and then assign the owners to that specific vulnerabilities, who will patch them, and also the completion date. So vulnerability scanning and finding the vulnerability is one part, then remediating and patching these vulnerability is actually done through action plan, which you can say is a structure, step-by-step roadmap that must have the prioritization, the owner, and the completion dates. Escalation pathways are basically formally defined workflows for raising the priority level and involving senior leadership when critical vulnerabilities remain unpatched past their deadline. So you set the deadline in action plan. So if that deadline is not met, and there are some critical vulnerabilities that are not patched or remediated as per the action plan, then we must escalate the issue with the senior leadership as per these escalation pathways. And remediation dependencies are recognizing and scheduling patch phases where one software update relies on previous infrastructure changes, for example, database updates. Next is what are some inhibitors to remediation, business, and governance. So these include the contractual agreements. So service level agreement, that is SLA, are third party service vendor contracts that restrict software changes or enforce strict uptime mandates. So these are the inhibitor. So we have found the vulnerabilities, now we want to remediate them, but there are some restriction or maybe some impediments in our way that make us delay the remediation, that are prohibiting us from remediation, and these include, as we studied, the SLAs or third party contracts, where we have signed the agreement that we cannot do the software changes without communicating to them or without their agreement, and we may have strict uptime mandates, and the patching may require downtime. Organizational governance is the complex change management, approval workflows, budget restriction, or lack of clear system ownership. So for patch management or for vulnerability remediation, we may require to invoke the change management approval. So since we are doing a configuration or change management, so this may also be a hindrance where we have complex approval workflows, or we have budget restriction where some remediation may require budgets, or lack of clear system ownership. Next is the business process interruption. So this is the operational risk that taking production system offline to perform patching will cause costly downtime or business disruption. So this is particularly important in the OT or ISS, industrial control system, where the uptime is very important. So the downtime that is required for remediation of vulnerabilities may disrupt the business process, and this may also be one of the inhibitors. Next is the technical obstacles in our remediation. So what are these? So these are degrading functionality. So there are some instances where applying a security page breaks critical API, internal software integration, or custom business logic. So we may have the page for the vulnerabilities, but it may degrade our system functionality, for example, breaking critical APIs, internal software integration, or some other custom business logic. So these are technical obstacles or technical impediments in our remediation path. Next is the legacy system. So these are the outdated end-of-life hardware or software that remains business critical but no longer receives official security updates from the vendor. So these systems, particularly important in operational technology, are also impediment in our remediation. Next is the proprietary system, which are specialized, custom-built internal applications that require rare development skills or specialized code modification to page safely. So we are continuing with the technical obstacles. So next is the page availability. So newly disclosed CVEs are active zero-day threats where the vendor have not yet written or released an official security update. So we may have found the vulnerabilities, but we may not have the page yet available for that specific CVE, either due to lacking or delay of the release from the vendor, or that the page is not yet available or written. Next is the stakeholder identification and communication with them, and these include the executive leadership, which is C-suite or board of directors. So this requires high-level summaries focusing on financial risk, overall threat trends, and regulatory compliance posture. Then we have the operations and IT teams, which require highly actionable and technical reports, exact host names, IP addresses, CVE numbers, and specific patching instructions. And lastly, the security teams, which coordinates remediation across departments, designs the compensating controls, and validates the applied patches and updates risk registers. So what are some metrics and key performance indicators, that is KPIs? So these are used for keeping the track of trends, so monitoring the total volume, severity, distribution, and age of open vulnerabilities over time to gauge defense effectiveness. So top risks are to maintaining the high visibility list of the most critical, highly exploitable vulnerabilities currently residing on high value business assets. SLA compliance is tracking the mean time to remediate MTTR against established organizational timeline, for example, fixing critical rated items within 14 days. And next is the security operation metrics that include the detection and training. So alert volume is monitoring the raw security alerts counts over time to guide defensive sensor tuning and combat analyst alert fatigue. False positive and true positive rates, so measuring the detection accuracy. High false positive rates points to noisy rules, whereas true positive validate the detection telemetry. Phishing campaign click rate, so quantifying applying vulnerability to social engineering over time to measure the effectiveness of internal awareness training. So if the applying click rate on phishing campaigns is low, it means your internal awareness training is working. If after the awareness training the click rate is reduced, it means that this KPI is good, it is working. If it is same or it has increased, it means we have to revise our internal awareness training. Objective 4.2, explain the importance of security operations and incident response reporting and communication, important topic. So the first topic is incident declaration and escalation. So incident declaration, when do we declare that this specific security event is an incident? So it is formally transitioning an active security investigation into an official declared cyber security incident. So it is no longer an event, it is now an incident after certain escalation criteria. So what is the escalation criteria? So we have to use predefined severity threshold, such as the amount of data exposure, the financial loss or system downtime to escalate the response. So for example, we may have the criteria that if the financial loss is more than $5,000, then it is an incident. If the downtime is more than, let's suppose, 10 minutes, it is an incident. And if the data exposed is more than of 10 users, then it is an incident. So these are just example. Each organization may have specific escalation and specific severity threshold to declare an incident. Workflow triggering is after declaring that it is an incident, we may formally activate the incident response team and bring in relevant external department on short notice. For example, we may activate the incident response. The incident response team will be activated, communication channel will be established, and layer 3 or whatever analyst or investigator we have may start working. So what is the incident executive summary and for whom it is purposed or intended? So this incident executive summary has a high level focus which translates complex forensic analysis and log captures into a clear overview of operational business impact and mitigation. So it is for high level executives such as CISO or CEO. So bottom line upfront of BLUF is giving busy executives a clear timeline of the breach. When did the breach occur? When it was detected? What is the current status? How many systems were affected? Are they contained? And the strategic recommendation in under 2 minutes. Next is the strategic resource needs. So it is outlining resource requirements, financial cost, and long-term security investments to prevent similar attack. Then we have the incident communication plan. For example, how do we communicate the incident to our legal and PR departments? So legal counsel is to manage the legal risk, protecting the forensic findings, and structuring critical data breach notification communication. Public relation or PR is developing clear and proactive media statements to manage corporate reputation and control public speculation. Media control is routing all the press and media inquiries strictly through a designated corporate spokesperson to prevent uncoordinated leaks. Then we have the external communication with external entities. So these may include the regulatory reportment. So complying with the strict legal timelines to report data breaches to official government bodies, for example, Security Exchange Commission, GDPR authorities, etc. So these may be included inside certain regulatory framework to report the breach or the incident in a certain timeline. For example, I think GDPR requires the breach notification in 72 hours. So these must be kept in mind during an incident. Law enforcement is coordinating with federal and local agencies, for example, FBI and cybercrime division without compromising ongoing forensic evidence. And then communication to the affected stakeholder or affected customer, which is constructing formal transparent notification to impacted user about exposed PII or PHI, personally identifiable information or personal health information, and outlining protective next steps. So these may be done through emails or through other communication channels. Next is the operational security, that is operational security awareness and channels. So out of bound channels are to avoid compromised corporate infrastructure like hacked emails and Slack, and using secure alternate communication channels. So for example, if the organization is under attack and their email server or some of their email accounts are hacked, so you don't need to use these communication channel, but use an alternate secure communication channel for the outbound communication. Operational security OPSEC is restricted incident discussions to keep active attackers from realizing they have been discovered on the network. So you do not need to disclose the incident information to the outside world unnecessarily, so that the attackers do not know that information that they have been discovered, and so that they are taken off guard by the organization. Internal messaging is to provide appropriate limited updates to standard employees to maintain corporate morale and prevent rumors. And next is the post-incident reporting. So it is after action report. So it is an extensive formal document chronicling the complete timeline, response, performance, and total impact of the incident. Lesson learned is conducting the structured post-mortem briefs to identify what went well, what failed, and how to improve future playbooks. And then we have the important root cause analysis, RCA. So it is a deep technical investigation to isolate the exact exploit vector or architectural flaw that allowed the intruder entry. So next is the shift handover and tailored threat intelligence. Shift and incident handover is structured transfer of open investigation, active alerts, and system statuses between operational shift to maintain continuity. Internal threat intelligence report is analytical reports focused on threat landscape, active campaigns, and adversary activity specifically targeting the organization. Organization and environment tailoring is filtering out generic global threat feeds to focus strictly on malicious vectors and targeting your internal technology stack. So what are some time-based KPIs in security operation metrics? So these include MTTD, that is mean time to detect, which is the average time elapsed from when an attacker enters the network to when the security team discovers the compromise. So the less is the MTD, the good is the detection time. So the one purpose of KPI improvement is to reduce this MTTD so that to detect the incident early as well as to prevent the large amount of system or network from compromise. Next is the mean time to respond. So the average time required to initiate containment actions after an incident has been officially declared. So when you have detected the event and then you declare that this is an incident, so this is the amount of time required to respond after declaration of incident, which include the containment of the containment actions such as containing the incident by isolating the affected system, blocking the threat actor IPs, etc. And then we have the mean time to remediate. So this is the average time taken to fully purge threat actor artifacts and restore system to verified clean state. So this is when you have contained the system. Now you want to remediate the system, which means the blocking of the attacker access, and remediate the vulnerability or the weaknesses due to which the attack was possible, and to restore the system to earlier cleaner stage. And last one is a mean time to close. So this is the total average time from initial alert ingestion to formal ticket closure. So this time is also important. This time is basically from the very beginning up to end. So this will be the longest time, but overall you need to reduce this time so that your incident time from end to end is reduced. So that's all for this domain as well as this course. So I had designed this course so that to give you early access to the newly launched CompTIA CySA Plus version 4 course. So I am confident that this will be of great help in your preparation for the CySA Plus exam as well as in your professional life. So my philosophy is to always go for the learning. So if you learn the content, if you learn the concept, if you learn the exam objective, you have two benefits. You will be able to pass the exam, but more importantly, you will be able to perform your task professionally in your professional field. So never just aim for the certification, aim for learning the content, aim for learning the concept, and you will achieve both the certification as well as your professional growth. So thank you. Please like this video, subscribe for more upcoming courses, and we'll see you.